I want to talk to you about percent questions. So we're going to take a look at a lot of different examples in this video, just because percent questions are really frequent on the ASVAB. So we're going to get started with some basic non-word problem questions that have to do with percents, and then we're going to go ahead and take a look at percent word problems. So if you're ready, let's get started. So let's jump into percents. In this lesson, we're going to be doing our very first word problems. These word problems are commonly found in your arithmetic reasoning section of the ASVAB. But before we get to the word problems, I want us to break down percents as an equation and really understand how to do this. And then once you understand how to do this, we'll get into word problems and then we'll make it more complicated. Okay? So first things first, let's understand something about the word percent. Okay? Per means for every, and cent means 100. So literally the word percent means for every 100. And why do I point that out? Because the way we solve this type of question, percent questions, is we're going to compare everything to 100. So a percent is out of 100 because it's a piece of 100. That's just kind of to explain where our equation comes from. In reality, our equation for percents is part over whole equals percent over 100. So it's saying a part out of a whole is a percent, which is a part also out of 100. That's basically what that means. So how do we use this equation? I'm going to show you that next. We're going to do this with really simple questions before we jump into the hard ones. In some of these questions, you might know a shortcut, and you might be tempted to multiply by a decimal, or whatever the shortcut you might have learned somewhere else is. I'm going to ask you to bear with me and use the equation instead, because the equation lets us use it for basically every single kind of percent question that there is under the sun, versus shortcuts can only be used in specific scenarios. Okay? So let's start with our very first question. Our very first question says, 20 is 40% of what number? Here, the word is, we should learn, belongs to part. The word of is associated with the whole. So when we see 20 is, this is the part. When we see 40%, that is easy to identify, that's the percent. And here it says of what number, it's telling us this is the whole. We don't know the whole because it's saying what number, so that's going to be different, and I'll show you that in a second. Let's plug stuff into our equation. Part goes on the top, that is 20. 40% goes on the other fraction on the top. The whole, it says what number. That means we don't know it. And whenever we have an unknown number, something we don't know, we can call it x. So we're going to put x there in the bottom. And 100 always goes here. Now, whenever we have two fractions that are equal to each other like this, what we can do is we can cross multiply them. X times 40 gives me 40x. 20 times 100 gives me 2,000. Now, I want to solve for x, and that 40 is multiplied to the x. So what I do to get rid of the 40 and get x by itself is I divide by 40. And whatever I do to one side of the equal sign, I have to do to the other side of the equal sign. So when I do this, this cancels out. I'm left with x by itself on one side of the equal sign. Here, I can cancel out a 0 that's in common on the top and the bottom because they're at the end of the number. This leaves me with 200 over 4, for 200 divided by 4. When I divide 200 by 4, what I get is 50. So x equals 50. What does this mean? This means that 20 is 40% of 50. If I take 40% of 50, I would get 20. Okay? I hope that makes sense. If it does not, that is completely okay. We're actually going to do another example that's just like it. If you want to give this one a try, you're welcome to hit pause and try it out. If not, or if you're ready, let's go ahead and review this one. So this one says 60 is, the is tells us this is the part. 30 has a percent, which means super easy, that one's a percent. Of what number? This would be the whole, but we don't know it, so it's going to be x. Now, let's plug this into our equation. Part over whole equals percent over 100. Let's plug that in over here. 60 is the part, 30% is the percent. I don't know the whole, so I call it an x, and 100 always goes down here. Now I'm going to cross multiply. X times 30 is 30x. 60 times 100 equals 6,000. The 30 is multiplied to the x. I want to divide it to get rid of it, but whatever I do on one side of the equal sign, I also have to do to the other side of the equal sign. That leaves me with x equals by itself. Here I once again can I can cross out a 0 that they have in common top and bottom. This leaves me with 600 divided by 3. 600 divided by 3 gives me 2. I bring down a 0, 0. I bring down another 0, 0. So x equals 200. Okay, I hope you got that. If you're ready, let's take a look at another example. If you notice in this example, the x, or the part that's missing, is the whole. Okay, we're solving for the whole. Let's take a look at another example where we're solving for something else. So here, 55 is what percent of 220? 55 tells me this is the part. What percent is telling me we don't know the percent. So that's what we're going to call x. Of 220 is the whole. So now that we have that, I just want to remind you that our equation is part over whole equals percent over 100. So let's start plugging stuff in. I'm going to do my equation over here on the side. So part is 55. We don't know the percent, so we're going to call it x. 220 is the whole, and 100 always goes down here. So 220 times x is 220x equals 55 times 100 is 5,500. I'm going to divide by 220 on both sides. Why? Because the 220 is multiplied to the x, and I want to get rid of it, so I divide. And whatever I do to one side of the equal sign, I have to do to the other. Here, I can cancel out a 0 top and bottom. I'm left with x equals 550 divided by 22. So now I'm going to divide this. Made some space. 22 goes into 55 2 times. 22 times 2 is 44. I subtract, I get 11. I bring down a 0. 22 goes into 110 5 times. Let's try that out. 5 times 2 is 10, carry the 1. 5 times 2 is 10, plus 1 is 11. So it is exactly 5. I multiply and I subtract here, And I got x equals 25%. And there we go. So 55 is 25% of 220. All right, let's go ahead and take a look at another example that once again is asking us for the percent. So if you like, go ahead and pause here and give this one a try. If you're ready, let's go ahead and get started with it. So this one, 48 this is the part. What percent tells us we don't know the percent, so it's going to be x. 160 is the whole. Just a reminder, our equation is part over whole equals percent over 100. So we can go ahead and plug stuff into our equation. 48 is, we don't know what percent, 160 is the whole, and 100 always goes down here. Let's cross multiply. 160 times x is 160x. 48 times 100 is 4,800. This 160 is multiplied to the x, so I'm going to divide so it cancels out. And remember, whatever I do to one side of the equal sign, I have to do to the other. So this leaves me with, I can cancel these zeros out, 480 divided by 16. I'm going to go ahead and divide. 16 goes into 48 3 times. 16 times 3 is 48. I bring down the 0, 16 goes into 0, 0 times, and I'm done there. So x equals 30%. That means that 48 is 30% of 160. Okay, I hope you got it. If not, feel free to go back and take a look at it again and figure it out. Take your time. If you're ready, let's look at another example. In this example, the percent is given to us, and the whole is given to us, but we're looking for the part. So what is, this is the part, which we don't know, so it's going to be x. 30% is the percent of 90 is the whole. Okay, so let's plug stuff into our equation. We don't know the part, so we're going to call it x. We do know 30%, and we do know that the whole is 90, and 100 goes here. So we're going to cross multiply. X times 100 is 100x, and 90 times 30 gives me 2,700. Now, I'm not working out the multiplication of those, but make sure that you are working out the multiplication when you're doing it yourself, okay? 100 is multiplied to the x, so we divide by 100. That cancels out on this side and leaves me with x equals. Here, I can eliminate 1 and 2 zeros at the end. That leaves me with 27 over 1, which is just 27. So what is 30% of 90? It's 27. So I think this one's a little bit easier than the other ones. Let's go ahead and take a look at another example just like it, okay? If you like, you can give this a try. If you're ready, let's go ahead and review it together. So here it says, what is, this is the part. 80% is the percent. I'm sorry, the part we don't know it, so it's x. And then of 60 is the whole. We're going to plug stuff into our equation. We don't know the part. We do know the percent. We do know the whole. And we know that 100 always goes down here. So now we can cross multiply. 100 times x is 100x. 60 times 80 is 4,800. The 100 is multiplied to the x. So we're going to divide on both sides. We can cancel out top and bottom, 2 zeros. I get x equals 48 over 1, which is just x equals 48. So what is 80% of 60? The answer is 48. Okay, great. I hope you got this. If not, take your time. You can go back and take a look at the different examples again. But if you're ready, the next thing I want to do with you is actual word problems. So now that we have reviewed how to do percents in a very simple way, what I want to do is start adding this skill of finding percents or working with percents to word problems. Okay, so we're going to start with some simple word problems, and then we're going to level up with the word problems. Okay, here we go. First one says, in a bag with 60 coins, there are 15 nickels. What is the percent of nickels in the bag? So here, the part and the whole are not so obvious. And the reason I say that is because when we're doing word problems, and a lot of people, I get this issue a lot when I'm working with students one-on-one, people just want to look at numbers and plug them in real quick and move on. But the truth of the matter is you really need to think. Word problems require thinking. You have to reason your way through it, okay? So, I'm sorry for the bad news, but we're going to have to think through this. So here's telling us that there's 60 coins and 15 nickels. Coins is referring to a bunch of different kinds, right? Nickels, dimes, quarters, pennies. There could be a lot of different coins in there. Nickels would be a type of coin. So this becomes the whole, and this becomes the part. All right? And what is the question asking us for? What is the percent of nickels? So that's important, okay? Because sometimes it will not ask us for nickels or the number that's given to us. It'll ask for something else. So it's always important to look at what is the percent it's asking for. So here, we put our two fractions equal to each other. We know that 15 is the part, 60 is the whole. We don't know the percent. 100 always goes here, okay? Now that we've done that, we can cross multiply. 60 times x is 60x. 15 times 100 is 1,500. I'm going to divide by 60 because the 60 is multiplied to the x, so I'm going to cancel it out. I remove a 0 at the end of each of these numbers, and I'm left with x equals 150 divided by 6. I have a lot of space on this other side on the left, so I'm going to do 150 divided by 6 over here. 6 goes into 15 2 times. 6 times 2 is 12. 15 minus 12 is 3. I bring down the 0. 6 goes into 30 5 times. 6 times 5 is 30. 30 minus 30 is 0. So here, my answer is 25%. Okay, so in reality, you should know how to do this by now, right? So that part is not going to be difficult. Now I think what's going to be challenging is figuring out how to translate a word problem, read and understand it, and then plug it into our equation. Or figure out how to use the equation to solve the word problem, basically, okay? All right, let's move on to the next question. So this next question says, in a bag of 200 coins, 60 of them are dimes. What is the percent of dimes in the bag? Okay, so this is a similar question to the last one. If you want to hit pause and try doing this on your own, I really encourage it. If you're ready to go over it, then let's do it. Here, this is a typo. This should be up. Sorry. Okay, here the 200 coins is our whole. Why? Because it's all of the coins. 60 are dimes. We know this is a part because this is a type of coin. okay? And it's asking us for the percent. And I did that weird, but that's okay. All right, let's go ahead and plug stuff into our equation. So part is 60 over 200. X is in a percent, and 100 always goes down here. We're going to cross multiply. 200 times x is 200x. 60 times 100 is 6,000. We're going to divide by 200 on both sides. This cancels out. And I do that so I can get x by itself. Here, I can eliminate 2 zeros. I'm left with 60 over 2. And 60 divided by 2 is just 30. So my answer here is 30%. Okay? I hope this is making sense. If you're ready, let's go ahead and level up and let's do something that's a little more difficult. All right, so in this next question, this is a little more challenging because this has a fraction in it, okay? So let's see what the question says. A shop sells 200 chocolate, vanilla, and strawberry ice creams in a day. 42 of the ice creams sold are vanilla, and 1/4 are strawberry. What percent are chocolate? All right, so here, it's asking for the percent of chocolate. So even though we have here 200 chocolate, vanilla, and strawberry, this is our whole. Because we're looking for the percent of chocolate, we have to find the part that is chocolate. So remember what I told you. We have to pay attention to the percent it's asking us for because the part needs to match it. If it's chocolate, then the part needs to be chocolate, okay? How do we find the part that's chocolate? It doesn't say that to us. It says 42 vanilla and 1/4 strawberry. Well, first of all, we know that 42 are vanilla. Let's start there. 1/4 strawberry. Well, let's find out what that is as a number. How do we find the fraction of something? We multiply by that fraction. So 200 times 1/4. I'm going to put the 200 over 1 so it's easier to multiply. That gives me 200 over 1 times 4 is 4. And 200 divided by 4 gives me 50. So there's 50 strawberry. And now we got to find out how many chocolate there are. I'm going to add these up. I get 92 vanilla and strawberry. And I'm going to do 200 minus 92 to get the number of chocolate. So that's 801. There are 108 chocolates. Okay? I'm going to erase this and make some space. So now this becomes my part. I'm going to set up my equation here because I want to find the percent. That's my goal, right? The part is 108. The whole is 200. I'm looking for the percent, so that's where the x goes, and 100 goes down here. So 200 times x is 200x. 108 times 100 is 10,800. I divide by 200. I cross out here, 0, 0. I get x equals 108 divided by 2. And when I do 108 divided by 2, what I get is 54. So 54% is my answer. So these questions are great because it takes, I want you to see that it takes extra work sometimes to be able to find the answer. It's not always a straightforward, just plug stuff into the equation. And that's why I told you earlier, you really need to think, okay? So remember, you can always go back, watch that explanation again, and if you have any questions, always feel free to leave a comment below. If you're ready, let's go ahead and look at a new kind of question. All right, let's go ahead and do this question. So this kind of question is what we call maybe like a sale price, or, you know, whenever we're dealing with money and buying something and getting a discount, we get a lot of questions like this on the ASVAB. And these questions are a little bit different. We still use our equation, but we do need to do extra steps. And the way we figure out those extra steps is by reasoning through what the question is asking us. So let's go ahead and read the question and let's get started. A television set costs $480 and has a discount of 30%. What is the price of the television with the discount applied? So here, I want to explain something about discounts. When we have like these types of questions, you'll see things like original price. This is our whole. Then we have sale price, and we have a discount. Let me make like a little chart for us here. Okay, so this is the part that we pay, and if we get a discount, this is a part that we don't pay. Think about it. If you get a discount, whatever they agree to give you as a discount, you don't pay for it, right? As a percent, the original price is considered 100%. The sale price is 8%, and the discount is another percent. Now, something important. The percent of the sale price and the percent of the discount add up. So percent discount plus the percent sale price add up to 100%. Okay? All right, so I know that sounds weird, but just wanted to give you that information. Let's see how it applies here. Here, it's telling us that the original price, or what it costs, is $480 before the discount. This is our whole. And then it's telling us that there's a discount of 30%, so this is our percent discount. Okay? But it's asking for the price after we get the discount. So it's asking for the part that we do pay. When we plug stuff into our equation here, $480, 100 always goes here, 30%, because this is the percent of the discount, we know that this will be the amount of the discount. What does that mean? That means that when we solve this, it does not give us our answer yet. It just gives us what the discount will be, okay? Let's cross multiply. 100 times x is 100x. 480 times 30. Let's do that math over here. 24. Okay, 14,400. Okay, I'm going to divide by 100. 1, 2. X equals 144 over 1, which is just 144. So this is my discount. Remember, it's asking me for the price, the part that we pay. So what am I going to do to find that price? I'm going to subtract 480 minus 144. So 10 minus 4 is 6, 7 minus 4 is 3, and 4 minus 1 is 3. So the price here is $336. Is this the part that they pay? Yes, which means we got this right.
Okay, so an important thing to notice here, it's really important to pay attention to what kind of percent it gives us and exactly what part it's asking us for. And notice I kept going back and checking, what is it asking me for? And then when I find an answer, I look back and I say, did I find that answer? And if I didn't, then okay, I keep going until I do find the answer. And I say that because sometimes people will get stuck here, and I can guarantee you that's going to be an answer choice. So you don't want to get stuck there and then get it wrong. It sucks to know how to do something, all these steps, and then get something wrong because you miss one last little step. So do not let that happen to you. Always go back and double check what the question is asking you for. Okay? All right, let's go ahead and do the next question. Okay, let's take a look at our next question. It says, James wants to buy a set of drums for $1,100. If the drums have a 20% discount, what is the price of the drums after the discount is applied? So this is very similar to the last question we did. If you want to hit pause and give the question a try, I really encourage you to do so. If you're ready, let's go ahead and review it. So he wants to buy the drums. This is the original price, which means this is our whole, and this is our percent discount, right? So when we plug it into our equation, what we're going to do is we're going to find the discount. But we have to remember that it asks for the price after the discount is applied. So we're going to find the discount, and then we're going to subtract it, yeah? Let's cross multiply. 100 times x is 100x. 1,100 times 20 is 22,000. I divide by 100 because I want to cancel this out and get the x by itself. And here, I'm going to eliminate 2 zeros, top and bottom, because that's what they have in common. And I'm left with 220 over 1, which is just 220. So just a quick reminder, this is our discount. Now that we've done that, we're going to subtract to be able to get the price. So here, I'm going to borrow, I don't have to do a lot. Just kidding. 0 minus 0 is 0. 10 minus 2 is 8. 10 minus 2 is 8. So the price after the discount is applied is $880. And remember, discount is applied just means we subtract the discount we find from the original price. Okay, I hope that makes sense. As always, if you have any questions, just leave a comment below. So in this question, what we're doing is we're finding the price after the discount, but here there's more than one item. So remember, we have to reason through it and figure out what the extra steps are, right? So a store is selling shoes at $38 a pair. If you purchase 2 or more pairs of shoes, you will receive a 30% discount. What is the price of 4 pairs of shoes? So the 4 pairs, remember, if it's 2 or more, they get a discount. So because it's 4 pairs and it's more than 2, boom, the discount gets applied, okay? So that's it. We don't have to worry about this information anymore. That's something to notice. Sometimes questions will give you extra information, okay? The price of each pair is $38. So what are we going to do? Let's find out first what the original price is of the 4 pairs. So 38 times 4. Why am I multiplying by 4? Because I can do 38 plus 38 plus 38 plus 38, or I just do 38 times 4. It's literally the same thing. 4 times 8 is 32. I carry the 3. 4 times 3 is 12, plus 3 is 15. So this is the original price, okay, or my whole. So now I'm going to put my equation together. I'm going to put 152 down here because that's the cost of 4 shoes. 100 always goes here. I'm going to put my 30% here. Remember, this is my discount. And I put the x here knowing that this is going to give me the discount. It doesn't give me the price. So 100 times x is 100x. And now 152 times 30, we're going to do that over here in this little corner. And for that is not supposed to be decimal point. Just in case, I don't want to confuse you. Okay, 1, 2, 3, placeholder 0. 6, 15, carry the 1, 4. So 45, 60. I divide by 100. Here, I can only eliminate 1 0. And I'm left with 456 divided by 10. So I'm going to divide by 10. I get 4, 5, 6. So here it's 45.6. That's my discount. Now I want to know the price. So I'm going to do 152 minus 45.6. I'm going to do that since we're going to go into cents, okay? 0, 10 minus 6 is 4, 11 minus 5 is 6, 4 minus 4 is 0, 1 minus 0 is 1. So this tells me that my price after the discount is applied for 4 pairs of shoes is $106.40, okay? So if you have any questions, please remember. So here's another kind of question. So here it says, a store is having a sale on basis and each face is $36. The sale price, so it's telling us that the $36 is the sale price. Remember, that means the price that we pay. The sale price of $36 is 20% off the original price. What is the original price of the vase? So here, this gets a little bit interesting. So with this one, what we're going to do is we know that 36 is the part. We do not know the whole. But this is the part that we pay, which means we cannot put the discount here because they don't match. Okay, so what do we do instead? We have to figure out the percent that we do pay. 100 always goes there, so I'm just going to fill that in. Well, remember, the percent of the discount and the percent that we pay add up to 100%. So 20 plus 80 gives us 100%. So 80% is the percent that we pay. Now that we have that, we cross multiply. 80 times x is 80x. 36 times 100 is 3,600. That 80 is multiplied to the x. To get the x by itself, I divide by 80, and I can eliminate a 0 top and bottom. That leaves me with 306 divided by 8. 8 goes into 36 4 times. 8 times 4 is 32. 6 minus 2 is 4. 3 minus 3 is 0. I bring down a 0. 8 goes into 40 5 times. So here, my answer is 45. Now, that is the whole, and that's what it's asking me for. Original price, remember, means whole. Okay? So we're going to stop here. In the next section of percents, I am going to go into a little more detail on some of these other questions. I just don't want to bombard you with a lot of examples. But there is a quiz below. Go ahead and give it a try. Some of them might look a little bit different, but remember, just reason through the question and figure out what steps you need to take. And remember, you always have your percent equation to help you. All right, good luck. says there are 30 red marbles and 45 blue marbles in a jar. I'm going to go ahead and review the questions from the quiz. There have been a couple of people asking about them. So let's start with number 1. It says there are 30 red marbles and 45 blue marbles in a jar with 200 marbles. What percent of the marbles are red? So we know that the total is 200 marbles. We know there are 30 red and 45 blue. And it's asking us what percent of the marbles are red. We're looking for the percent. So we're going to set up our equation. Part over whole equals percent over 100. Because it's asking us for the percent, we know that we're going to do this. We're going to use this one as our x. What are we going to put for the parts? Well, we're going to put 30 because it's asking us the red. And our whole is going to be 200. So let's set this up a little nicer. So 30 over 200 equals an unknown percentage over 100. Okay, so let's cross multiply. 200x, which is what we get from multiplying 200 times x, equals 30 times 100, which is 3,000. We're going to divide by 200 because we want to get the x by itself. We can cancel out the zeros that it has in common. I don't cancel out this 0 right here behind the 3 because there are no more zeros in the bottom. So what I'm left with is x equals 30 over 2, and 30 divided by 2 is 15. So my answer is 15%. Okay? I hope you got it. If not, don't worry. I'm going to erase this to make some space. Let's move on to number 2. So number 2 says, there are 40 students in the classroom. 12 of those students have laptops. What percent of the students in the classroom do not have a laptop? So here we have our whole, 40 students. We have parts, which is 12, that have laptops. And we're looking for, the question is asking us for the percent. So we're going to put that x for the percentages. But it says the percent of the students that do not have a laptop. Okay? So that means we're going to have to do some subtraction at the end. But let's set it up with the information that we do have so far. We know there are 40 students that have a laptop. Sorry. Let's try it again. We know that there are 12 students that do have a laptop, 40 in total. We want a percent over 100. So we're going to do 40x, which is 40 times x, equals 12 times 100, which is 1200. We're going to divide by 40 on each side to isolate the x. We can eliminate one zero that they have in common. 120 divided by 4 is 30. Now, that is not the answer yet, because it says do not have a laptop, and this is the number that do have a laptop. We're going to subtract it from 100. Why do we subtract it from 100? Because 100 is the percent whole. Okay, so 100 minus 30 is 70%. If this is a percent that do have a laptop, this is the percent that do not have a laptop. So our answer is 70. Another way of doing this, I'm going to erase everything real quick to show you another method. Another way of doing this is saying, if I want to know the number that do not have a laptop, I'm going to put, if I want to know the percent that do not have a laptop, then I'm going to put up here the number that do not have a laptop. And if there's 40 students in the classroom and 12 of them do have a laptop, that means 28 of them do not have one. So I can put 28 do not have a laptop is going to be the same as a percent that do not have a laptop. This is over the total of 40 students in the class, and 100 always goes here. So 40x is 2800. I'm going to divide by 40. 280 divided by 4 gives me 70%. Either way, it's correct. It'll give you the right answer. It just depends on the way you understand it a little bit better, okay? All right, I'm going to make some space, and we're moving on to the next question. Question number 3. Question number 3 says, Susan earned $200 for a job she completed last week. If she spends 35% of her income on groceries, how much of her earned income did she spend on groceries? So we know that she earned $200. And out of those $200, 35% of it was spent on groceries. And it's asking how much did she spend on groceries. We want to know the part. So our whole is 200. Our part is x because we don't know how much it's going to be that she spends on groceries. But here we do put the percent that she spends on groceries. And we always put 100 here. So we're going to cross multiply 100x. 200 times 35 is 7,000. We're going to divide by 100 so we can isolate the x. And remember, we can always divide when we have a lot of zeros at the end. We can eliminate the zeros that they have in common top and bottom. We can't eliminate that last zero right there because there are no more zeros on the bottom. So I'm left with x equals 70 over 1, which is just x equals 70. So that's my answer. All right, let's keep going. Number 4. There are 350 people at a school event. 280 of those people are adults. What percentage of the total people at the event were children? So here, we know that there are 350 total people. We know that 100 always goes here. It's asking the percentage of children. Out of all of these 350 people, 280 of them are adults. So how do I find out the number of children? I'm going to subtract 350 minus 280. This becomes 15, 70. There are 70 children at this event. So now that I know the number, now I can find the percent of children. So I'm going to do 350 times x is 350x. 70 times 100 is 7,000. I'm going to divide by 350. I'm going to eliminate one zero because that's what they have in common. And then I'm going to divide. So 35 goes into 70 exactly 2 times. 35 times 2 is 70. I have to bring down the other zero. So 35 goes into 0 times. And that gives me, there's nothing else to bring down, so I'm done. So the answer is x equals 20%. Okay? All right, this one I do have to erase and make some space, and we'll move on to the next one. Double check your answers, double check how you're working out the question. You might, if you're getting any of these wrong, it could be that you're getting some of the arithmetic wrong. Just try to figure out what you're doing wrong. And try to, if you're getting them right, awesome, keep going. But if you're getting something wrong, just try to figure out what kind of questions it is, what part you messed up, and maybe do more questions that are similar to it. Don't just ignore the questions you're getting wrong. Try to learn from the stuff you're getting wrong so you can get better. Okay, now that I said that, let's do number 5. So James has to read 60 pages of his textbook for homework. If James read 12 pages on the school bus on his way home from school and 6 pages after eating a snack, what percent of the pages assigned has James already read? So we're looking for percent that he has already read. 100 always goes here. My total is 60 pages. And I'm looking for percent that he has already read, so I have to put the number over here that he has already read. So he's read 12 pages on the school bus and 6 pages after eating a snack. So 12 plus 6 is 18 that he's read in total. So I'm going to do 60 times x, 60x, because I need to cross multiply. 18 times 100 is 1800. And I'm going to divide by 60 so I can isolate the x. I eliminate 1 0, because that's what they have in common. And then I'm going to do 180 divided by 60. 6 goes into 18 3 times. 6 times 3 is 18. I need to bring down that 0. So 6 goes into 0 0 times. And now I've brought down all the numbers and I'm done. So my answer is 30%. That is what he has already read. Okay, looks good. Let's clean this up a bit and let's keep going. Number 6. Paul collects coins from different countries and has a collection with 220 coins. If he sells 33 coins, what percent of his collection did he sell? First things first, what is the question asking us for? What percent, so we're looking for percent of what he sold, or what he sells, right? My total is 220, and what he sells, or my part, is 33 coins. Okay, so let's set it up. 33 is the part out of 220. We're looking for the percent, so we're going to call that x, and 100 goes here. Why is the 33 here and the x here? Well, because we want to know the percent that he sells. So we put an x where the percent goes, and we compare it to the number that he did sell, which is 33. So now I'm going to cross multiply. 220x equals 3,300. So I'm going to divide by 220, and I'm going to eliminate a 0. So that leaves me with 22 goes into 303. 22 goes into 33 one time. 22 goes into 110 5 times. I'll show it to you right here. 5 times 2 is 0. Carry the 1. 5 times 2 is 10. Plus 1 is 11. So that gives me 110. So now that I've confirmed that for you, 22 times 5 is 110. I brought down the 0 to do 110, so I don't have to bring down any other numbers. And my answer is 15. Okay? Okay. Let's keep going. Let me erase a bit and make some space. All right. Questions S. Chris was paid $1,600 for the last 2 weeks of work. He paid $800 for his rent and $160 for his car insurance. What percent of his income did he spend on rent? So it's asking us for a percent again. Okay? And it's asking us for the percent he spent on rent. Well, rent was $800 and his total income was $1,600. So we're going to put rent as a part and the total as $1,600. We want to know what number that is. So we're going to call it x. Sorry, what percent that is. We're going to call it x. And 100 always goes here. So 1,600x equals 80,000. We're going to divide by 1,600. I'm going to eliminate some zeros. And we have 800 divided by 16. Awesome. So here, we have to ask ourselves, how many times does 16 go into 80? Well, I don't know that off the top of my head, so let's kind of estimate, okay? So let's say I know that 16 times 2 is 32, and 16 times 3 is 48. So I'm going to go a little bit higher. Let's do 16 times 4. 4 times 6 is 24, so I'm going to carry the 2. 4 times 1 is 4 plus 2 is 64. Now that's pretty close, but it looks like we can go a little bit higher. So let's try 16 times 5. 5 times 6 is 30, so I'm going to put the 0, carry the 3. 5 times 1 is 5, plus 3 is 8. So 16 times 5 is exactly 80. So 80 minus 80 is 0. I'm going to bring down that 0. 16 goes into 0, 0 times 0, 0, 0. 50%. All right. Let's keep going to number 8. So Jennifer had 30 chocolate candies in her bag. She ate 6 candies with her lunch, 2 candies later in the afternoon, and she gave her coworker 4 candies. What percent of the candies does Jennifer have left? So we're looking for percent that she has left. Well, then we have to figure out the number she has left. She started out with 30, that's her total. We know we're looking for percent, so we're going to call it x, and 100 always goes here. So let's see how much she had left. It tells us what she ate or gave away, right? So from there, we can kind of just add them up and subtract them from the total. So 6 plus 2 is 8, plus 4 is 12. 6 candies at lunch, 2 candies later in the afternoon, that's 8. 4 to her coworker, that's 12. So she ate 12. How many does she have left? 30 minus 12 is 18. So that's what we're going to put here. Let's go ahead and cross multiply. 30x equals 18 times 100, which is 1800. We're going to divide by 30, and we're going to eliminate a 0. And we're going to do, let me do the division for you. 3 into 180, or 180 divided by 3. So 3 goes into 18 6 times. 3 times 6 is 18. 18 minus 18 is 0. We do have to bring down that other 0. Okay, we're left with 60%. Looks good. All right, let's keep going. More than halfway there. Number 9. Diana spends 2 hours at the gym. She spends 30 minutes on the treadmill. What percent of her time at the gym does she spend on the treadmill? So, this one, we're looking once again at the question. It's asking us a percent of time that she spent on the treadmill. So, we're going to put X here because that's what we're looking for. 100 always goes here. It tells us she spends 30 minutes. I'm going to put minutes on the treadmill. Okay? And it tells us that she spends a total of 2 hours at the gym. This is not the same unit, so I have to convert hours to minutes to be able to use it in this equation, okay? So how many minutes are in 2 hours? There are 60 minutes in 1 hour, which means I have to multiply it by 2, which gives me 120 minutes. Okay? So now that we've done that, let's cross multiply. 120x equals 3,000. We're going to divide by 120. We're going to eliminate some zeros. And now we're going to do 300 divided by 12. So 12 goes into 30 2 times. When we divide that, 12 goes into 60 5 times. 12 times 5 is 60. 60 minus 60 is 0. There's no more zeros to bring down, so our answer is 25%. All right, I'm going to make some space. Number 10. Greg has 36 ounces of water in a water pack. If he drinks 40% of the water in the pack, how many ounces of water does he have left? So this one, let's find out. We want to know how many ounces of water he has left. So why don't we find out how many ounces of water he drank, and that way we can figure out how much he has left. Why are we going to do that? Because it doesn't tell us what percent of water he has left. It tells us the percent that he drinks. So that's why we're going to have to do it, with subtraction. So let's start off with our equation, always. Our total is 36 ounces. That's how much the water in the pack originally. 40% of it has been drunk by Greg, and we don't know what that number is, but we're going to call it X, and 100 always goes here. So 100 times X is 100X, and 36 times 40 is a bigger number than we normally work with. So let's multiply out. 0, 0. 4 times 6 is 24. Carry the 2. 1440. So I'm going to divide by 100, and I can eliminate 1 0. So 144 divided by 10. So 10 goes into 14 one time. Times 1 is 10. I'm going to bring down the 4. 10 goes into 40 4 times. 40. I have a 4 left over. So I'm going to add a decimal. Add a 0 and bring it down. 10 goes into 40 4 times. And now I'm done. So this is the number that he drank. What is the question asking us for? What he has left. So we have to do 36 ounces minus 14.4. We're going to add a decimal and a 0 here so we can subtract. This becomes a 10. I'm going to make this a 5. 10 minus 4 is 6. 5 minus 4 is 1. And 3 minus 1 is 2. So our answer is 21.6. Okay? Okay, looking good. We're almost there. Let's go ahead and take a look at the next one. I hope you're getting these. Remember, you can always pause, go back, think about it, take a look at it. Try to figure out where you're messing up, okay? All right. So, number 11 says, Samantha pumped 13 gallons of gasoline and filled up the tank of her car. She traveled to a city that was 20 miles away and used 30% of the gasoline in her car. How many gallons of gasoline did Samantha use? Okay, so what was the total? 13 gallons. What is the question asking us for? The number of gallons that she used. And it gives us the percent that she used. So it looks like it's going to be pretty straightforward. 100 always goes here. 13 gallons is what she started with. She used 30% of that. And we want to know the number that she used. So we don't have to subtract anything because this number, X, is going to match the 30%. This is the number that she used, and this is the percent that she used. That looks good, okay? All right, let's cross multiply. 100 times X is 100X. 13 times 30, let's do 13 times 30. 9, that's 390. I'm going to divide by 100. I'm going to eliminate a 0. And now we're going to do 39 divided by 10. So 10 goes into 39 3 times. We're going to subtract by 30. Subtract by 30. 9 minus 0 is 9. I can't have something left over, so I'm going to add a decimal and bring down the 0. 10 goes into 90 9 times. And there we go. My answer is 3.9 gallons. If you were still confused about, if you're messing up with this part here, then I encourage you to go back and take a look at the section or the videos on multiplication and division. And that should help you understand a little bit better what's going on. I don't want you to, get questions wrong because of mistakes with arithmetic, with division. So I encourage you to go back and double check those and make sure you understand how to divide them, okay? All right, here we go, let's keep going. We're doing great. Number 12. There were 35 rabbits in a pet store. If 20% of the rabbits were sold in the morning, what number of rabbits were sold? We're looking for the number of rabbits sold. So this is a part. 35 rabbits is the total number of rabbits, and it says that 20% were sold in the morning. So it's already giving me the percent, just kind of straightforward. So 20% of the rabbits were sold, over 100. There are 35 rabbits in total, and putting an X here is going to help me find the number of rabbits that were sold. So I'm just going to cross multiply. 100 times X is 100x. 35 times 20 is 700. And I'm going to divide by 100. I'm going to eliminate the zeros that they have in common. And that gives me x equals 7. There's my answer. I hope that made sense. Can you erase this to make some space? Let's keep going. Number 13. Cassandra ate 12 candies, which were 20% of the candies in the bag. How many candies were in the bag before Cassandra ate any? Okay. Here, it's asking us for candies that were in the bag before Cassandra ate any, which means the total, because nothing was taken away. So we're looking for the whole, which is here. Remember, 100 always goes here. And it tells us that 12 candies were eaten, and that this is 20%. So we know the number of candies that were eaten, and we know that this is equal to 20%. So just to make this clear, 12 is 20% of this number, and that's why this works. So one more time, 12 is 20% of this number, and that's why this equation works. Okay? Now let's cross multiply. 20 times x is 20x. 2 times 100 is 200. And I'm going to divide by 20. I'm eliminating a zero that they have in common. Oh, just realized what I did. I erased a number by accident. 12. Let's try it again. 20 times x is 20x. 12 times 100 is 1200. There we go. Those numbers make more sense. Okay. We're going to divide by 20. And now we have 2 into 120, or 120 divided by 2. So 2 goes into 12 6 times. 2 times 12 is 12. Minus 0. Minus equals 0. We're going to bring down that 0. 2 goes into 0 0 times. So my answer is 60. Okay, number 14. It says, a machine makes rubber ducks. The machine makes 320 rubber ducks by noon. If the machine has already made 40% of the daily goal by noon, what is the daily goal? So it's asking us the daily goal, which is the total. And it tells us that it's already made 320, and that this is 40% of the daily goal. So this 320 is a part of the total. And it's, to be exact, 40% of the total. So that's why I'm going to put that there. Now that I've done that, I can cross multiply. 40x equals... How did I get this? Whenever I multiply a number by 100, I write that number, and then I add the 2 zeros from 100 behind it. Okay? So now I divide by 40. I can eliminate 1 0. And I have 4 goes into 3200. 4 goes into 32 8 times. 4 times 8 is 32, and 32 minus 32 is 0. I have to bring down the next 0. 4 goes into 0 0 times. And I have to bring down the next 0. I can't stop until all the numbers have been brought down. 4 goes into 0 0 times. So my total is 800 ducks. Remember, when you are multiplying a number by 100, we write the number and we add the 2 zeros. So the number was 320, and then I added 2 more zeros. Okay? Just a couple little shortcuts to save you time. And last but not least, number 15. There are 21 boys in the classroom. If boys make up 60% of all the students in the classroom, how many students are there in the classroom? So here, we know that 21 boys are parts. To be exact, 60% of the entire number of students in the classroom. So 21 boys is the parts, 60% of the whole. And we're going to look for the whole because it's asking us how many students are in the classroom. That's the total, okay? So we're putting the x where the total goes. And we always put 100 over here. So now we cross multiply. 60 times x is 60x. 21 times 100. Remember, we write the number, and then we add the 2 zeros for 100. We're going to divide by 60. We're going to eliminate a 0. And we're going to do 210 divided by 60. So 6 goes into 21 3 times. 21 minus 18 is 3. We bring down the 0. 6 goes into 30 5 times. 6 times 5 is 30. 30 minus 30 is 0. And I've brought down all the numbers, so I'm done. So what's the total number of students in the classroom? 35 students. Okay, I hope that was helpful. Make sure to try to figure out where you're messing up. If it's multiplying and dividing, go back and take a look at that video and do some of the practice. If not, keep going. You're doing great. Hi there, thank you for joining us. This is a proportions video. In this video, I will teach you to solve proportion problems. We will take a look at the equation to use, review the steps to solving with the equation, and practice with some more problems. Okay, let's get started. So proportion questions can take many shapes or forms, but all proportion questions can be solved with one equation. First, let's look at the equation you should use to solve the proportion problems. Proportion questions make comparisons between two different scenarios. These scenarios are basically comparing ratios, so it's important for you to learn how to identify a proportion question. Proportion questions compare two scenarios to each other, meaning the ratios are equal to each other. I hope that makes sense. We'll look at some questions, and hopefully it'll help to move the idea along a little bit better. Okay, so the equation that we're going to use for proportion questions is really simple. It's a lot like the percentage equation. Essentially what you're doing is comparing one fraction to the other, because you're saying that the ratio in this fraction is equal to or proportional to the ratio of this fraction. So I know this looks funny because it's apples to oranges, but I promise I'm going to prove a point. But what I want you to understand first is that scenario 1 is being compared to scenario 2. And the reason these questions are called proportion questions is because this ratio or this fraction is proportional or equal to the other one. So that's how we can compare these two scenarios. I hope that makes sense. So the next thing I want you to understand, and the reason I have the apples and oranges for you, is that the top and the top have to be the same, and the bottom have to be the same. So if we're comparing buckets, it has to be buckets to buckets. So the buckets in scenario 1 have to be in the same position in the equation as the buckets in scenario 2, or the apples in scenario 1 have to be in the same place as the apples in scenario 2. Same thing goes with the bottom, okay? So if we misplace them and we don't put them in the right place in the top and the bottom, we are more than likely not going to get the right answer. So one more time to make sure you understand, scenario 1 is the first fraction, scenario 2 is the second fraction. We're comparing these two and saying that their ratio is proportional or equal to each other. And we have to make sure that these things match, okay? We also have to make sure if we're working with units that the units are the same. All right, so let's go ahead and take a look at some questions to make sure you understand how to put this into practice. I promise once you start using it, it's gonna make a lot more sense. All right, let's go. So let's go ahead and look at some examples. A photograph is 4 inches wide and 6 inches long, and it is enlarged so that it is 6 inches wide. What is the length of the enlarged photograph? Go ahead and try it on your own, and then I'll come back and work it out with you. Welcome back. How'd it go? I hope you got it. If you didn't, don't panic. I'm going to go over the question with you now. Let's go ahead and take a look at the givens. Remember, we start with the givens, we understand what the question is asking us for, and then we solve. So the givens basically say that one picture is 4 inches wide, the other one is 6 inches long. So that's going to be our scenario 1. Let's set it up. 4 inches wide. Now, I like to write everything out because I want to make sure that I'm putting everything in the right place and I don't want to get confused, especially with this question that everything is in inches. So it can be a little confusing like that. So this is the width, and we're comparing it to 6 inches in length. All right, let's put this here. So we're saying that this ratio or this proportion is proportional or equal to our scenario 2. Well, what is scenario 2? Scenario 2 would be the enlarged photo. Now, what do we know about the enlarged photo? We know that the width of the enlarged photo is 6 inches. So let's put that up here because we put the width of the photo up here. So that means we have to put the width of the second photo up here. So 6 inches wide. And do we know the length? No, we do not. So we're going to call that x. All right? So let's go ahead and cross multiply. Whenever we have two fractions equal to each other, we can always cross multiply, no matter what the scenario is. If there's nothing else multiplied to them or added to them, and these things are aside, they have an equal sign in the middle, just cross multiply them. So 4 times x is 4x, and 6 times 6 is 36. Easy, right? So now we have to solve for x. We do that by dividing by 4, and we get x equals 9. So that means that the length of the enlarged photo is 9 inches. All right, I hope that makes sense. If you didn't get it, go over it again and make sure you understand. If you do, then let's move on to the next question. The question says, it takes 4 buckets of water to wash 3 windows. If a building has 8 windows, how many buckets of water will be needed to wash all of the building's windows? All right, go ahead and give the question a try, and then I'll work it out with you. How'd it go? I hope you got it. I'm sure you did great. If not, don't panic. We're going to go over it together now. So remember, we start out with givens, then we look at the question, and then we solve it. All right? So the givens are for this question. 4 buckets of water to 3 windows. That's scenario 1. 4 buckets, 3 windows. All right? The second scenario is unknown buckets. That's what the question is asking us for, and 8 windows. All right, so let's put it in our equation, and let's see how to work it out. So we have 4 buckets for every 3 windows. As you can see from this question, proportion equations can be used for almost anything, right? So that's scenario 1. Scenario 2, we have no idea how many buckets we need, so we're going to call that x. So x goes up here, but we do know that we are going to wash 8 windows with these buckets. So we're going to set it up in the bottom. Windows and windows are the same. There are denominators, and buckets, when we solve for this x, that means we're solving for buckets. Got it? All right, let's cross multiply because that's what we can do every single time we have one of these questions, when we have a fraction with an equal sign and another fraction. So 3 times x is 3x. 4 times 8 is 32. We're going to divide by 3 because we want to isolate the x. 32 divided by 3, is not an even division. So we're just going to work it out and try to get it to maybe like one number behind the decimal point. So 3 into 32. 3 goes into 3 one time. Sorry, that's a 0. We bring down the 2. 3 goes into 2 0 times. We can add a 0 and bring it down. But if we do that, remember we have to put a decimal point up here, okay? 3 goes into 20. Oh, sorry about that. 6 times. 3 goes into 26 times. 3 times 6 is 18. 20 minus 18 is 2. So we have 10.6, and we're going to stop there because if not, it's going to get a little complicated. The question is asking us for buckets. Now, when you get buckets of water, do you get 10.6 buckets of water? No, you'll get 11 buckets. So we're going to round that up to the next one. So we can answer this question by saying 11 buckets of water. All right, I hope that made sense to you. If not, go over the steps again. Take your time, make sure you understand before moving on to the next one. If you got it, then let's go ahead and keep practicing together. Let's go ahead and do another question. Our recipe calls for 2 cups of water for every 1.5 cups of flour used. If Sarah only has 2.5 cups of flour, how many cups of water will she need? Go ahead and give it a try, and we'll work it out together. Go. Did you get it? I hope you did. I hope it's making a little more sense. If not, don't worry about it. We're going to go over it step by step. So let's remember, we start off with givens. So let's go ahead and look at the givens together. So scenario 1 is 1.5 cups of flour for every 2 cups of water. Okay? So we're going to put that in a fraction of scenario 1. So 2 cups of water. Because all of this is in cups, I'm going to go ahead and write what the cups are of so we don't get confused. So 2 cups of water for every 1.5 cup of flour. Okay? So we're going to put that here. This is scenario 1. This is our recipe. Now, scenario 2 would be what we actually have, or what Sarah actually has. So she has 2.5 cups of flour. And notice we put this in the bottom. We put this in the bottom because we know that in scenario 1, we put the flour in the bottom. So in scenario 2, we have to put the flour in the bottom as well. So the question is asking us for how much water she will need. We know that's our unknown. It's the only given that we don't have. So we're going to call this x. So we cross multiply because that's just what we do when we have two fractions equal to each other. 1.5 times x is 1.5x. Now we're going to set that equal to 2 times 2.5, which is 5. We're going to divide by 1.5 to isolate the x. And we're going to go ahead and work this out. So to be able to divide when you have a decimal out here in the divisor, what you have to do is you have to move this decimal. You can't have one. You have to get rid of it. In a whole number, essentially the decimal is at the end of the number. So we have to move the decimal 1 over to the right the same way we did outside, okay? Which means we add a 0. So 15 into 50. That's what our problem turns into. 15 goes into 50 3 times. 15 times 3 is 45. 45 minus 5. I'm sorry, 50 minus 45 is 5. Now we can go ahead and annex a 0 and bring it down. Remember, we would add the decimal up here as well because we added a decimal on the bottom. 15 goes into 50 again 3 times. You'll notice that this is a repeating one, so we're not going to keep going and making this more complicated. We're going to leave it here. So we know that she's going to need approximately 3.3 cups of water. And that's it. We solved the problem. So I hope this made sense to you. If it didn't, go ahead and watch it again and go through the steps. Look to see what you did wrong, maybe when you did it, if you got it wrong. If you got it, then great. Let's go ahead and move on to the next question. 6-foot man is standing next to a tree. The man's shadow is 8 feet long and the tree shadow is 20 feet long. If the length of the shadow is proportional to the height of the subject, what is the height of the tree? All right, give it a try. I hope you got it. This one is a little complicated, so don't worry if you didn't. We're going to go ahead and work out that problem together. All right, here we go. So scenario 1 gives us a 6-foot tall man next to a tree. We don't know how tall the tree is, all right? But we know that his height is 6 feet and that the tree's height will be x feet. We don't know how much it is, so we're going to call it x. So we're going to make that scenario 1, 6 over x, because that's our actual. We're going to do scenarios as actual and shadow, okay? So I'm going to put it up here so it's easy for us to remember. Actual versus shadow. So we know that the man is 6 feet tall, but we don't know how tall the tree is. But we do know their shadows, right? And their shadows are 8 feet for the man and 20 feet for the tree. So far so good. Scenario 1 is the actual height. Scenario 2 is the shadow height. All right, so let's go ahead and cross multiply. 6 times 20 is 120, and that's equal to 8x because 8 times x is 8x. We're going to divide by 8 so that we can go ahead and isolate the x and solve. And let's set that up over here. 8 goes into 12 one time. 12 minus 8 is 4. We bring down that 0. 8 goes into 40 5 times. 8 times 5 is 40. 40 minus 40 is 0. So the tree is 15 feet tall. Okay, I hope that made sense. What made that a little complicated was actually setting up the scenarios, but I'm sure you got it. If you didn't, go back and go step by step, see where you messed up and how you can improve for the next one. If you got it, let's move on to the next question. A map has a key that indicates that every 1.5 inches on the map is equal to 200 miles. If Brownsville is 2.5 inches away from Greensville on the map, how many miles apart are the towns? Go ahead and give it a try. This is the last question, so I hope you made a count. Let's go ahead and look at the givens together. So we know that scenario 1 is 1.5 inches on the map. That's the distance of the map to 200 miles, which is the actual distance, right? And we're comparing the distance, we're comparing the scenario to the distance between 2 towns on a map. So let's have scenario 1 as our key, all right? So scenario 1, we have 1.5 inches is to 200 miles. Scenario 2 gives us the inches and then asks us for the miles. If you look at the question, it says how many miles apart are the towns. So 2.5 inches on the key and x miles, because this is our unknown and it's what we're looking for in our question. So let's go ahead and multiply stuff. So 1.5 times x is 1.5x. 200 times 2.5, I'm sorry, we know that 2 times 2.5 is 5, and then we have 2 zeros, so 500. And then we divide by 1.5 so we can isolate the x, and we set that up in a division problem right here. Now we've gone over this before. Remember I told you when we have a decimal on the outside, we can't have that, we don't want it there. So we have to move that decimal point over 1, and because this is a whole number, we're going to move it over 1 here, and fill that gap in with a 0. So this question is rewritten as 15 into 5,000. So 15 goes into 50 3 times. 15 times 3 is 45. 50 minus 45 is 5. Bring down the 0. 15 goes into 50 3 times. 15 times 3 is 45. 50 minus 45 is 5. And we bring down the other 0. I know it feels like we're doing this a lot, but we have to make sure we use up all the zeros before we stop, because if we don't, we won't get the right answer. So 15 goes into 50 again 3 times. So 15 times 3 is 45. 50 minus 45 is 5. So we know that the distance between the 2 towns is 333 miles. All right, I hope that made sense. If not, go back. You know how we do it. We go back, we check, we look at our steps, and see where we went wrong. Okay? Good luck. I hope you found this problem helpful. If you didn't understand any of the steps, make sure to watch the video again or contact us for any additional help. Remember to practice and use all of the resources available to you. Practice, 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 practice. Practicing will get you the score you want. Thank you for watching and good luck. Okay, so I'm going to go over this quiz with you. I'm going to explain how to do each question. If you have any questions, please feel free to leave a comment below and I'd love to help you with it. Now, something that I want to say about these quizzes. They are similar questions. So I kind of added different kinds of questions, and you'll notice that a lot of the questions are similar, some of the questions are similar. The reason I do that is because I want to give you a chance to practice something again and again until you become very good at it, okay? So I'm doing it because I want you to score high on the ASVAB. I don't want you to think that I'm just adding random questions because I ran out of questions to give you. So if you saw me explain a question and the next one is kind of similar, feel free to hit pause and try that question now that you know how to do it, okay? So with that said, let's go ahead and get started. Question number 1 says, a farmer uses 3 gallons of insecticide concentrate to spray each half acre of his land. How many gallons of insecticide concentrate does he need to spray 14 acres? So for this one, we're going to use our proportion equation, which is 2 fractions equal to each other. One fraction, we put one scenario. In the other fraction, we put the other scenario. So let's try to figure out the 2 scenarios. 3 gallons of insecticide for each half acre. This is a scenario. 3 gallons for every half acre. And then it says how many gallons, we don't know, so we're going to call it X, to do 14 acres. If you notice, gallons and gallons are together in the top, acres and acres are together in the bottom. Okay, that's super important. So now let's cross multiply, because whenever we have 2 fractions equal to each other, we just cross multiply. 1/2 times x is 1/2 x. 3 times 14, let's do it here on the side. 3 times 4 is 12, carry the 1. 3 times 1 is 3 plus 1, 42. And now there's this 1/2 that's multiplied to the x. So I'm going to multiply by 2 to get rid of the 1/2. And whatever I do to one side of the equal sign, I do to the other. So when I do that, I cancel this out, and I get 42 times 2. 2 times 2 is 4, 2 times 4 is 8, x is equal to 84 gallons. And there we go. Some people see this and they're like, oh, I was able to do it in my head. That's great. I'm glad that you were able to figure it out. However, some people do need to work out the math. And that's why I do all the math, all the multiplication, so you can see it, because I don't want to lose you. I want you to understand. I'm moving on to number 2. Number 2 says, a blueprint for a building shows that a room is 12 inches long and 8 inches wide. If the room is actually 28 feet wide, what is the length of the room? So, 12 inches long, 8 inches wide. This is one scenario. And then it gives us wide and asks us for length. That's scenario number 2. So 12 inches long, 8 inches wide. And then it gives me 28 feet wide. There's a problem here. We have to have the same unit, and we don't. So what do we have to do? We have to convert this. So 28 feet as inches. How many inches is that? We don't know. Sorry, let me fix that. We don't know how many inches that is, but we do know that 1 foot equals 12 inches. So now I'm going to do x, 28 times 12. 16, carry the 1. 2 times 2 is 4, plus 1 is 5. Placeholder 0. 1 times 8 is 8. 1 times 2 is 2. 6, 13, 3. So 336 inches. Okay, so now that we have this in inches, we can put this here. And now we're going to find out how many inches long this is. So let me make some space. Let's cross multiply. 8 times x is 8x. And 336 times 12, we're going to calculate over here. 2 times 6 is 12. 2 times 3 is 6, plus 1 is 7. 2 times 3 is 6. Placeholder 0. 1 times 6 is 6. 1 times 3 is 3. 1 times 3 is 3. We add them up. 2, 7 plus 6 is 13. 1 plus 6 is 7, plus 3 is 10. We get 4,032. Now we're going to divide by 8 on both sides. 8 goes into 40 5 times. 8 times 5 is 40. Bring down the 3. 8 goes into 3 0 times. 8 times 3 is 0. Bring down the 2. 8 goes into 32 4 times. There's nothing else to bring down. There's nothing left over. So x equals 504 inches. But my answer choices are in feet, which means I have to convert this back to feet. So let's make some space and let's make it happen. So 504 inches is x number of feet. And we know that 12 inches is 1 foot. Let's cross multiply. X times 12 is 12x. 504 times 1 is 504. I'm going to divide by 12 to isolate the x. And now, actually I don't have enough space there. Now I'm going to do 504 divided by 12. So 12 goes into 50 4 times. 12 times 4 is 48. 50 minus 48 is 2. I bring down the 4. 12 goes into 24 2 times. 12 times 2 is 24. 24 minus 24 is 0. So this is 42 feet. And there we go. This one was a little bit longer just because we had to convert with the inches and the feet and all that. Okay, when you're ready, let's move on to number 3. Number 3 says, a map has a key that indicates that every half inch on the map is equal to 40 miles. If Blakemore is 4.5 inches away from Ellesmere on the map, how many miles apart are the towns? So my 2 scenarios are half inch is equal to 40 miles. And 4.5 inches is x miles. So 1/2 of an inch is 40 miles. 4.5 inches is x miles. Now that we've done that, let's cross multiply. 1/2 times x is 1/2 x. And 40 times 4.5, we're going to calculate. 5 times 0 is 0. 5 times 4 is 20. Placeholder 0. 4 times 0 is 0. 4 times 4 is 16. So there's one number behind the decimal point here. So there'll be one number behind the decimal point. My answer is 180. Now I have a 1/2 multiplied to that x, so I'm going to multiply by 2 to cancel it out. Whenever we have a fraction, we can multiply by the denominator to cancel out the denominator, okay? So this becomes x is equal to 180 times 2, 0, 16, carry the 1. 2 times 1 is 2, plus 1 is 360. So my answer is 360 miles. Okay, I hope you got it. Let's go ahead and move on to number 4. Number 4 says, 8 pounds of salt are needed to treat 12 miles of icy road. If there are 27 miles of icy road in Louisville, how many pounds are needed to treat the roads? So my 2 scenarios are 12 miles of icy road, take 8 pounds of salt. So 8 pounds of salt is 12 miles. How many pounds do we need for 27 miles? Let's cross multiply. 12 times x is 12x. And 27 times 8 is, 8 times 7 is 56, carry the 5. 8 times 2 is 16 plus 5 is 21. We're going to divide by 12. Let's do this division problem now. Okay, 12 goes into 21 one time. 21 minus 12 is 9. Brings down to 6. 12 goes into 96 8 times. 12 times 8 is 96. 96 minus 96 is 0. X equals 18 pounds. There we go. I think you're noticing how important it is to know how to multiply, add, subtract, divide. If you are still kind of like stuck with it, I would recommend you go back and try doing the arithmetic section again, just so you can be really good with multiplication and division and addition and subtraction, because you need it for these questions. Okay, number 5. A farmer uses 2.5 gallons of insecticide concentrate, 2.5 gallons, to spray each quarter acre of his land. How many gallons of insecticide concentrate does he need to spray 8.5 acres of land? So let's set it up. 2.5 gallons is equal to a quarter acre. X gallons is equal to, or is over 8.5 acres. Okay, so let's cross multiply. A quarter times X is a quarter X. Now this is where it gets kind of complicated. 2.5 times 8.5, well, that's a decimal and a fraction. So what we're gonna do is we're gonna convert that fraction into a decimal. So we take the fraction part and we divide the numerator by the denominator, which means the numerator, or the top number, goes in the inside and the denominator goes in the outside. So 1 divided by 2. 2 goes into 1 0 times because 2 is bigger than 1. So we're actually going to add a decimal and a 0. 2 goes into 10 5 times. 2 times 5 is 10. 10 minus 10 is 0. I'm done. So this is 8.5 is a 0.5. So now this becomes 2.5 times 8.5. So let's do it over here. 2.5 times 8.5. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. Placeholder 0. 8 times 5 is 40. Put a 0, carry the 4. 8 times 2 is 16, plus 4 is 20. So I'm going to add them up, 5, 2, 1, 2. There are 2 numbers behind the decimal point in my question, which means there's 2 numbers behind the decimal point in my answer. So 21, 25. Now, I'm going to erase all this and make some space. Now, when we have a fraction here, remember I told you, we can multiply by the denominator to cancel it out. So whatever I do to one side of the equal sign, I must also do to the other. So this becomes x equals, let's do 21, 25 times 4. 5 times 4 is 20, carry the 2. 4 times 2 is 8, plus 2 is 10, 0, carry the 1. 4 times 1 is 4, plus 1 is 5, and 4 times 2 is 8. There are 2 numbers behind the decimal point in my question, which means there are 2 numbers behind the decimal point in my answer, and my answer is 85. Awesome. Let's go ahead and do number 6. A blueprint for a building shows that a room is 8 inches long and 6 inches wide. If the room is actually 15 feet wide, what is the length of the room? So this is pretty similar to that question that we did earlier. So if you want to take a look at it, or you want to give it a try on your own, you're more than welcome to do so. If not, if you're ready, then let's go ahead and get started. So it tells me 8 inches long, 6 inches wide. 8 long. Sorry, I forgot to put the unit. 8 inches long, 6 inches wide. And it says that the room is 15 feet wide. Now, these are not the same units, so once again, I have to convert this. 15 feet is an unknown number of inches, but you know that 1 foot is equal to 12 inches. So let's cross multiply. X is equal to 15 times 12. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3, placeholder 0. 1 times 5 is 5, 1 times 1 is 1, 0, 8, 1. So X is 180 inches. So now I can convert this to 180 inches wide. And this is going to be X inches long. So let's cross multiply. 6 times X is 6X. 180 times 8, I'm going to calculate over here. 8 times 0 is 0. 8 times 8 is 64, so I put a 4, carry the 6. 8 times 1 is 8, plus 6 is 14. So I have 1440. And I'm going to divide by 6 on each side. Let me do that division problem. 1440 divided by 6. 6 goes into 14 2 times. 6 times 2 is 12. 14 minus 12 is 2. Bring down the 4. 6 goes into 24 4 times. 24 minus 24 is 0. And even though this is 0, I still have another 0 to bring down. So 6 goes into 0 0 times. And now I'm done. So X equals 240 inches. But we want to know the length in feet. So now we have to convert this to feet. So I'm going to erase and make some space. 240 inches is to X number of feet. And 12 inches is to 1 foot. So X times 12 is 12X. 240 times 1 is 240. I'm going to divide by 12 to isolate the X. And I'm going to do this division problem. 12 goes into 24 2 times. 12 times 2 is 24. I bring down the 0. 12 goes into 0 20 times. And that's it. I'm done. So X equals 20 feet. And that's my answer. Okay, let's continue with our proportions questions, and let's look at number 7. Number 7 says, a nursery owner mixes 3 pounds of manure into every 12 pounds of soil. If the nursery owner has 8 pounds of manure, how many pounds of soil can he prepare? So we have 3 pounds of manure, 12 pounds of soil, 8 pounds of manure, 2 X pounds of soil. So let's set it up. And because everything is in pounds, I'm going to do pounds manure, 12 pounds soil, 8 pounds manure, X pounds soil. Okay, now that I've done that, let's cross multiply. 3 times X is 3X. 8 times 12 is 96. We're going to divide by 3 on both sides. 3 goes into 9 3 times. 3 times 3 is 9. 9 minus 9 is 0. Bring down to 6. 3 goes into 6 2 times. 3 times 2 is 6. 6 minus 6 is 0. So the answer is 32 pounds. There we go. I have to make some changes, so that's why it looks like that. But the answer is 32 pounds. Okay, let me erase a little bit, make some space for number 8. It says, Kent is trying to make lemonade. He usually likes to add 2 tablespoons of lemonade powder to 1.5 cups of water. If he wants to make 7.5 cups of water, how much lemonade powder does he need? So it's 2 tablespoons of the powder, 1.5 cups of water. So 2 tablespoons to 1.5 cups of water. And this is equal to 7.5 cups of water and x tablespoons. So 1.5 times x is equal to 2 times 7.5. So actually we should do this for both of this. These are both 1/2. What is 1/2 written as a decimal? Well, it's 1 divided by 2. 2 goes into 1 0 times. 2 goes into 10 5 times. 1/2 is 0.5, which means that we can change these to 1.5 and 7.5. And I'll do it here too. So what's 2 times 7.5? Well, let's see. 2 times 5 is 10, carry the 1. 2 times 7 is 14, plus 1 is 15. There's one number one number behind the decimal point in my question, which means there'll be one number behind the decimal point in my answer. So 1.5x is equal to 15. Now I'm going to divide by 1.5 on each side so I can isolate the x. Sorry, I'm just trying to make some space here. 1.5. Let's actually divide over here. 1.5 into 15. So we don't like decimals on the outside. So we actually have to move that decimal point over one space. And because this is a whole number, that decimal point is at the end. So we're going to move it over one space also and fill it in with 0. So this is 50, 15, and 150. So now how many times is 15 going to 15? Once. I have a 0 to bring down still, so I bring it down. This becomes 10. And we're done. So x equals 10 tablespoons. There we are. I hope you got that. When you're ready, let's move on to number 9. Number 9 says, a shop owner uses 5 ounces of glass cleaner to clean 8 of his shop windows. If he only has 3.75 ounces of glass cleaner left, how many windows can he clean? 5 ounces of glass cleaner to 8 windows. So 5 ounces, 8 windows. He only has 3.75 ounces, so I'm going to put that up here with the other ounces, and I don't know how many windows that's going to be. Perfect. So now I just cross multiply. 5 times x, 5x. 3.75 times 8, let's find out what that is. 8 times 5 is 40, carry the 4. 8 times 7 is 56, plus 4 is 60, carry the 6. 8 times 3 is 24, plus 6 is 30. There are 2 numbers behind the decimal point in my question, so there'll be 2 numbers behind the decimal point in my answer, and that gives me that. Now I divide by 5, so I can isolate the x. 30 divided by 5 is just 6 windows. I hope you got it. Let's move on to number 10. Number 10 says, Hillary is painting her house and needs to paint 42 square feet of walls. 18 ounces of paint can cover 12 square feet. How many ounces of paint does Hillary need? So 18 ounces covers 12 square feet. Let's write that one first. 18 ounces, 12 square feet. This is equal to how many ounces? We don't know, so we're going to call it x ounces. But we do know that we need to cover 42 feet. So now let's cross multiply. 12 times x, 12x. 18 times 42, I don't know, let's calculate it. 8 times 2, 16, carry the 1. 8 times 4, 32, plus 1, 33. Placeholder 0. 1 times 2 is 2. 1 times 4 is 4. Now let's add it up. 6, 5, 7. So 12x equals 756. Let's divide by 12. 12 goes into 75 6 times. 12 times 6 is 72. 75 minus 72 is 3. Now I bring down my 6. 12 goes into 36 3 times. 12 times 3 is 36. 36 minus 36 is 0. So my answer is 63 ounces. There we are. Okay, awesome. Let's move on to number 11. Number 11 says, a nursery worker mixes 3 pounds of manure into every 15 pounds of soil. If the nursery owner has 22 pounds of manure, how many pounds of soil can he prepare? So 3 pounds of manure for every 15 pounds of soil. So 3 pounds manure, 15 pounds of soil. And he has 22 pounds of manure, so 22 pounds manure, x pounds of soil. So now let's cross multiply. 3 times x is 3x. Let's find out what 22 times 15 is. 5 times 2 is 10, carry the 1. 5 times 2 is 10, plus 1 is 11. Now placeholder 0. 1 times 2 is 2, 1 times 2 is 2. Let's add it up. 0, 3, 3. 3x equals 330. Now I'm going to divide by 3 so I can isolate the x. So 330 divided by 3. 3 goes into 3 one time. Bring down the next 3. 3 goes into 3 one time. Even though I have a 0 to bring down, so I still have to keep going. 3 goes into 0, 0 times. Now I have no more zeros to bring down and I have nothing left over, which tells me my answer is 110 pounds. Awesome. That was pretty straightforward. I'm going to make a little bit of space here. When you're ready, let's move on to number 12. If you're doing any of these and you weren't able to do them before, but now that I'm explaining how to do them, you understand a little bit better, feel free to hit pause and give it a try. And then when you're ready, just hit start again and we'll keep going. So number 12, Dylan is trying to make lemonade. He usually likes to add 5 teaspoons of lemonade powder to 2.5 cups of water. If he wants to make 8 cups of water, how much lemonade powder does he need? So 5 teaspoons for every 2.5 cups. 5 teaspoons for every 2.5 cups. We don't know how many teaspoons he needs for the next scenario, but we do know he wants to make 8 cups. This, we're going to turn it into a decimal. If you remember, 1/2 is just 1 divided by 2. 2 goes into 10 5 times. So 1/2 is just 0.5. So we're going to rewrite this as 2.5 cups. Now that we've done that, it's going to be easier to cross multiply. So 2.5 cups are equal to 5 times 8, which is 40. Now, sorry, not cups. X. Sorry about that. So now we're going to divide by 2.5 so we can get the x by itself. And I'm going to do 40 divided by 2.5. But I need to get rid of that decimal point, so I do this instead. So this becomes 400 divided by 25. So 25 goes into 40 one time. Bring down to 0. 25 goes into 150. I believe it's 6 times. 6 times 2 is 12 plus 3, 15. So our answer is x equals 16 teaspoons. Awesome. Okay, let's move on. Number 13. It says, a shop manager uses 9 ounces of glass cleaner to clean 6 of his shop windows. If he only has 7.5 ounces of glass cleaner left, how many windows can he clean? So we have 9 ounces for 6 windows. So let me start plugging that into my equation. 9 ounces, 6 windows. But he only has 7.5 ounces. How many windows? Perfect. So 9x is 9x. 7.5 times 6. 6 times 5 is 30, carry the 3. 6 times 7 is 42 plus 3 is 45. There's one number behind the decimal point in my question, which means there will be one number behind the decimal point in my answer. So 9x equals 45. I divided by 9 on both sides to isolate the x, and 45 divided by 9 is 5 windows. Awesome. Let's go ahead and move on to number 14. Number 14 says, Christina is painting her house and needs to paint 25 square feet of walls. If 8 ounces can cover 10 square feet, how many ounces of paint does Christina need? So we have 8 ounces is equal to 10 feet. And we need 25 feet done. So how many ounces is that? So 10 times x is 10x. And 25 times 8, 8 times 5 is 40, carry the 4. 8 times 2 is 16 plus 4 is 20. So 10x equals 200. I divide by 10 on each side. Look at that, I can eliminate a 0. X equals 20. She needs 20 ounces of paint. Awesome. All right, let's look at the last question for this quiz. And it says, Jeremy is preparing a mixture. The directions call for 3.2 grams of sodium hydroxide for every 6.4 fluid ounces of deionized water. Jeremy only has 2 grams of sodium hydroxide. How many fluid ounces of deionized water does he need? So 3.2 grams is to 6.4 fluid ounces. But we only have 2 grams, so how many fluid ounces is that? So 3.2 times x is just 3.2x. And 6.4 times 2, well, that's easy. Let's do that over here. 2 times 4 is 8. 2 times 6 is 12. There's one number behind the decimal point. Now I'm going to divide by 3.2 on each side so I can isolate the x. But I have a decimal out here, so I have to move it once, which means I move this decimal also. And that's what I get. So how many times does 32 go into 128? Well, 3 times 4 is 12. So I'm going to try 32 times 4. 4 times 2 is 8. 4 times 3 is 12. So yep, it's exactly 4. So the answer is x equals 4 fluid ounces, which is the second one. Let me erase this so we can see better. Awesome. Okay, so that's it for this quiz. I hope you got it. I know that it's very repetitive, but that's on purpose. Remember that we have to repeat things again and again so we get good at it. You're not going to get a high score because you knew how to do a proportion question once and it came out good. You're going to get a high score because you've done a bunch of proportion questions and you've done good on all of them, okay? So let's keep going. You're doing an awesome job. Good luck. Hi, this is Natalia Cardona with ASVAB Success, and in this video, I want to review with you some simple interest questions. These questions are usually word problems and they're found in the arithmetic reasoning section of the ASVAB. So if you're ready, let's get started. So before we get started with the first question, I want to show you the equation for simple interest. So the equation is interest earned equals principal times time over 100. Okay, what does this mean? Interest earned, I is interest earned, P is principal.
I wish I never
which is usually the deposit,
downloaded the Misspell
R
app because
is some interest rate, and T is time in years. Super important, it's time in years, okay? All right, so now that we have our equation set up, make sure you write that down, take a screenshot if you need to, okay? Let's go ahead and work on the first question and see how this applies. I am going to move this over right there, so we can always look at it. Okay, so first one says, Henry receives $850 in gifts for his graduation. If Henry decides to save all of the money in a savings account that earns 3% simple interest,
because I never know
3%
what
interest,
to
sorry,
order
how much
with
interest
the
would Henry have
DoorDash
earned in 4
cars.
years? So this question doesn't say it, but the way we can tell regular percent questions and simple interest questions apart is a simple interest question will say simple interest or something of that nature, okay? So how do we do this one? First of all, it tells us that he puts $850 in this account. So right off the bat, because this is how much he deposits into the account, we know this is the principal, okay? 3% interest is going to be our rate, and the time is 4 years. It's asking us how much interest, so we know what we're looking for is the interest earned. That is going to be our unknown. So I'm going to plug everything into our equation. Interest earned, we don't know, so we leave it as I, equals, our principal is $850, times 3, which is our rate, times 4, which is time, in years, divided by 100. Before we divide anything by 100, let's go ahead and start multiplying stuff up here. So I'm going to multiply the easy stuff first. 3 times 4 is 12. So 850 times 12 over 100. I'm going to do 850 times 12 in this corner over here because I have some space. Gives me 0, 10, carry the 1, 16 plus 1, 17. Placeholder 0, 1 times 0, 1 times 5, 1 times 8. And I add these up, 0, 0, 12, 10. So this gives me 10,200 over 100. I cancel the two zeros out on the top and the bottom because they have them at the end, and I'm left with interest earned equals 102 over 1, which is just $102. So in this question here, how much does he earn in 4 years? It's $102. So simple interest is pretty easy in the sense that all we do is plug stuff in and then solve, okay? All right, I hope that makes sense. Let's go ahead and take a look at another example. So this question says, Stacy wants to earn $600 in interest so she can buy a car. She puts $3,000 into an account that earns 4% simple interest. How long will Stacy need to leave her money in the account to earn $600 in interest? So just as a reminder, our equation is I equals P times R times T divided by 100. Here, if she puts $3,000 into the account, we know this is our principal. $600 in interest is repeated twice, but it is our interest earned. 4% interest is our rate. And it's asking us how long, which means the time is what we don't know this time. So if you notice, the questions can change depending on where things are, right? Like what is given to us, what is not given to us. So let's plug stuff into our equation. It's going to look different this time because we have interest earned and what we're missing is time. So I equals, so 600 equals principal, which is 3,000, times 4, which is our rate, times time, which we don't know, so we leave as t, and we divide this by 100. Okay, so let's start with 3,000 times 4. That gives us 12,000. We divide this by 100. Guess what? We can eliminate some zeros here. We're left with 600 equals 120 over 1 is just 120 times t. And now I'm going to divide by 120 on both sides. I do that because I want to get the t by itself. I can cancel out a 0. And now I'm going to do 60 divided by 12, which is just 5. So time equals 5. And remember, time is always in years. So 5 years. Okay? I hope you got that. If you didn't, that's okay. You can rewatch this example. Remember, it looks a little bit different because instead of missing interest, now we're missing time. Okay? All right. If you're ready, let's move on to another question. So here's our next question. I'm going to rewrite our equation up here so we don't forget it. PRT over 100. Okay, so it says, Jennifer deposited $1,200 into a savings account that earns simple interest. If she earns $144 in interest in 4 years, what is the simple interest rate on the account? All right, so let's identify stuff. Deposited, principal. Earns interest, interest. 4 years, time. What is the simple interest rate? That's what we're looking for this time. Okay, so remember, step number 1, we always identify what's given to us. All right, let's start plugging stuff in. I equals, so 144 equals 1,200 times, we don't know the rate, times 4, all over 100. Okay, 1,200 times 4, when we multiply it, gives us 4,800 times r over 100. We can cancel out some zeros. We're left with 144 equals 48 over 1, which is 48 times r. And now we're going to divide by 48 on both sides. This cancels out, and I'm left with r equals. So now 144 divided by 48. 48 times 2 gives me 96. 14 minus 6 is 8. 13 minus 9 is 4. So it's actually times 3. I'm backtracking. 48 times 3. Let me double check that. That's 24. Carry the 2. It's exactly 3. Perfect. So my rate is 3%. And there we are. Okay. So now that we have that, I want to show you one more example. Remember, we're moving around, right? The first one, we're missing interest earned. The second one, we're missing the time. The third one, we're missing the rates. So we can keep moving things and unknowns around on our equation. Let's look at another example. All right, next question. So before we jump in, I'm going to write our equation as usual. Okay, let's go ahead and read the question. It says, Kate deposited $4,800 into a savings account that earns 5.2% simple interest. What will her account balance be after 3 years? So this one's a little bit different. This one says account balance. Account balance means whatever we deposited or what Carla deposited all that time ago, plus however much interest she earned. This is equal to account balance. Okay, so we already know the principal. What we need to find here to find the account balance is the interest earned. So let's identify stuff. Deposited $4,800, that's our principal. Okay, and a savings account that earns 5.2 simple interest, that's the rate. We're looking for the account balance, but first we have to find the interest earned, and this is after 3 years, which is the time. So remember, we're looking for account balance, which means we have to find the interest earned. So interest earned equals 4,800, which is our deposit or principal, times 5.2 times 3, all divided by 100. Okay? So let's start actually with 5.2 times 3. That gives me 615. One number behind the decimal point in my question, 1 in my answer. So times 15.6 over 100. Here, we can actually eliminate these zeros here, and that leaves us with 48 times 15.6 over 1. So let's do 48 times 15.6. Okay, 48, carry the 4. 24 plus 4 is 28. Placeholder 0. 5 times 8 is 40, carry the 4. 5 times 4 is 20, 24. 2 placeholder zeros. 1 times 8, 1 times 4. We add these up, 8, 8, 10, 14, 7. We have one number behind the decimal point in my question. We have one number behind the decimal point in my answer. So here, the interest earned is 748.8. Now, we go back to the question. The question is asking for account balance, which means we need to add the principal plus the account balance. We're going to put 2 zeros because it's money. 0, 8, 8, 4, 15, 5. So the account balance is $5,548.80. So if you remember in percent questions, we talked about how these word problems, we have to reason through them, okay? So here we did have to add an extra step of adding the deposit plus the interest earned to get account balance. That's basically what we're doing here, okay? All right, remember, if you have any questions, you can always leave a comment below. And if you're confused about this, go back and watch it again. You can completely and totally do that. If you're ready, let's move on to another question. Okay, so this next question, I'm going to start out as usual, I equals PRT over 100. Okay, so John has a savings account with a balance of $684 that earns 2% simple interest. If you originally deposited $600 into the account, how long ago was this deposit made? So here what they're giving us is account balance. This is not the deposit, this is the account balance, okay? 2% simple interest rate is our rate. Originally deposited $600, that is our principal. And it's asking how long ago, so it's asking us for the time. If you notice, what we're missing here is the interest earned, right? Well, can we find the interest earned? Yes, because we know that interest earned by principal gives us account. So what we have to do is actually subtract. Let's find out how much this account has earned by subtracting what was originally deposited from the actual balance. And when we do that, we get $84. This is the interest earned. Okay, now that we have that, let's plug stuff in. Interest earned equals deposit for principal times 2% times time over 100. So here we can do what we did last time and cancel stuff out early, which leaves us with 84 equals 6 times 2 times t over 1, which is just 6 times 2 times t. So 84 equals 12t. I can divide by 12 on both sides to cancel this out and get the t by itself, and 84 divided by 12 is 7. So here, my answer of the time is 7 years. So in this example, we see that we can use account balance if that's what's given to us to find the interest earned, or we can even find the principal, okay? All right, I know I threw a lot of examples at you, so I hope this makes sense. You do have a quiz below so you can practice, and remember, if you have any questions, just leave a comment. Today I'm going to start doing simple interest. This is a simple interest quiz. I'm going to review the questions with you and answer maybe any questions you might have about the questions in this quiz. So let's start with number 1. It says Jesse deposited $6,800 into a savings account that earns 1.5 simple interest. How much interest will he have earned after 8 years? Well, first of all, let's remember our equation for simple interest. Our equation is I equals P times R times T. Okay, where I is interest earned, P is the principal, or the amount that we start with. The rate is a percent, but it's written as a decimal. And T is time in years. Okay? All right, so now that we have all of that we remember it, let's go back to our question. It says that Jesse deposited $6,800. This sounds like what he started with, okay? And he has a 1.5% simple interest, which means that is our rates, or our R, okay? And it's asking us how much interest will he have earned. We're looking for I, okay? And it's telling us 8 years. It's in years, it's our time. So we have everything we need to be able to plug into this equation. So I equals principal, which is $6,800, times the rate, which is 1.5%. We have to divide this by 100, which means we're going to move this decimal point 2 places to the left. 1, 2. And that empty space there, we fill it with a 0. One more time. When we divide by 100, we move the decimal point 2 spaces to the left, and we fill in any empty spaces with a 0. So this becomes 0.015, or 0.015. It's the same thing, okay? And times time, which is 8 years. So I always like to multiply the larger number to the smaller number. So I'm going to do these two first. Let me make some space. Okay, so 6,800 times 0.015. 5 times 0 is 0, 5 times 0 is 0, 5 times 8 is 40, carry the 4, 5 times 6 is 30, plus 4 is 34. Now a placeholder 0, and now I do the 1. 1 times 0, 0, 1 times 0, 0. 1 times 8, 8, and 1 times 6 is 6. Now, I don't have to multiply these zeros because it's just going to give me a bunch of zeros and that's going to waste my time. Now I'm going to add it up 0, 0, 0. 4 plus 8 is 12, so I carry a 1. 1 plus 3 is 4, plus 6 is 10. Now I go back here and I say, wow, there's 3 numbers behind the decimal point, so my answer, there will also be 3 numbers behind the decimal point. So now I can rewrite this as 102 times 8. So now I'm going to do 102 times 8. 8 times 2, 6, carry the 1. 8 times 0 is 0, plus 1 is 1, and 8 times 1 is 8. So this is $816. Okay? I hope that made sense. I'm going to erase and make some space to move on to number 2. When you're ready, let's do number 2 together. So it says, Kevin wants to save up for his first car. If he deposits $900 into a savings account, that earns 6% simple interest. So this is how much he deposits, which is principal. This is our rate. So P, rate. How many years So time is what we're looking for. Does he have to leave the money in the account so he earns 540 in interest? Okay, it looks like we have everything we need for equation. So let's start plugging stuff in. 540 interest is equal to a 900 principal times the rates. Remember, we divide by 100. Here, it's a whole number. The decimal point is at the end. So we go 1, 2, fill it in with a 0. This is 0.06. So I'm going to put 0.06. And the time, we don't know it. We're going to leave it just like that. So now let's multiply 900 times 0.06. 900 times 0.06. 6 times 0, 0. 6 times 0, 0. 6 times 9 is 54. There are two numbers behind the decimal point, so there'll be two numbers behind the decimal point in my answer. So now I'm going to do 540 is equal to 54 times t. I'm going to divide by 54 so I can get the t by itself. Let me do it over here. So 540 divided by 54. 54 goes into 54 one time. I still have a 0 left over to bring down, so I'm going to bring it down, and that gives me 10. I have no more numbers to bring down. I have nothing left over, so t equals 10 years. And there we go. I hope you got it. I'm going to move on to number 3 now. So when you're ready, number 3. Jocelyn deposited $1,100 into a savings account that earns 3% simple interest. In how many months will Jocelyn have earned $231 in interest? Couple things here. Deposited $1,100, that means principal. Earns 3% simple interest, that is rates. How many months? It's asking us for time. And it's telling us interest, so this is I. Okay? Now pay attention here. It says months. When we find t is in years. So that means that we have to convert it to months when we're finished. Okay? Let's plug everything in and let's get to work. So interest is $231 equals $1,100 that were deposited times 3%, which we divide by 100. 1, 2. This becomes 0.03. And we don't know time. That's what we're looking for. So we're going to multiply 1,100 times 0.03. 3 times 0 is 0, 3 times 0 is 0, 3 times 1 is 3, 3 times 1 is 3. And in my question, there are two numbers behind the decimal point, which means in my answer, there will also be two numbers behind my decimal point. So this is 231 equals 33t. I'm going to divide by 33 so I can isolate the t. And now let's see what that gives me. So 33 does not go into 23 because 33 is too big. So I'm just going to have to kind of get as close as I can to it. So we're going to actually estimate this. So I'm going to round the 33 to 30, and I'm going to say, well, 30 times 7 is 210. And that's pretty close, right? So let me give it a try, 33 times 7. So I'm going to do that over here, 33 times 7. 7 times 3 is 21, carry the 2. 7 times 3 is 21 plus 2 is 23. So that actually works perfectly. I don't have anything else to bring down, so t equals 7 years. So are we finished? No, it said months. So we have to convert this to months. Well, how many months are there in a year? There are 12 months. So 7 times 12 is 84 months. Let me move this out of the way. That's my answer right there. Okay? Hope you got it. When you're ready, just move on to number 4 with me. Number 4 says, Greg deposited $2,800 into a savings account that earns 3.5% simple interest. How much interest will he have earned after 4 years? So he deposited, this is principal, 3.5% simple interest, that's rates. How much interest? So we're looking for I, and time is 4 years. Now that we've identified everything, let's just plug it in. So interest is unknown, so I'm just going to leave it as interest, or I. Principal is $2,800 times the rates that I'm going to divide by 100. 1, 2. This becomes 0.035. Like that. And time, 4 years. So now I'm going to multiply. 2,800 times 0.035. So 5 times 0 is 0, 5 times 0 is 0, 5 times 8 is 40, carry the 4. 5 times 2 is 10 plus 4 is 14. Now placeholder 0, let's do 3. 3 times 0 is 0, 3 times 0 is 0, 3 times 8 is 24, so 4, carry the 2. 3 times 2 is 6, plus 2 is 8. So 0, 0, 0, 8, 9. Okay? How many numbers are behind the decimal point in the question? 1, 2, 3. So there'll be 1, 2, 3 in the answer. So I is equal to 98. This becomes 98 times 4. So let's do that math real quick. 4 times 8 is 32. Put the 2, carry the 3. 4 times 9 is 36. Plus 3 is 39. So interest equals $392. And there we go. Okay, let's move on to number 5. It says, Lucy deposited $2,200 into a savings account that earns 5% simple interest. How much interest will she have earned after 6 years? So here, once again, it gives us the principal. It gives us the interest. Sorry, not the interest, the rate. It asks us for interest. And it gives us time. If you want to hit pause and give this one a try right now, you're more than welcome to. If you're ready, then I'll go ahead. Let's plug everything in. So we're going to just call it interest equals principal, which is $2,200, times rate, which is 5% divided by 100. 1, 2. Remember, this is a whole number, so decimal is at the end, okay? So now I plug in 0.05 times 6. So now I'm going to multiply these two together first. 2200 times 5. Oh, sorry, not 5, 0.05. 5 times 0 is 0, 5 times 0 is 0, 5 times 2 is 10, carry the 1. 5 times 2 is 10, plus 1 is 11. And there are two numbers behind the decimal point, which means there will be two numbers behind the decimal point in my answer. So this becomes 110 times 6. So 110 times 6, 6 times 0 is 0, 6 times 1 is 6, 6 times 1 is 6. That's $660 in interest. There we go. When you're ready, let me make some space here. Let's move on to number 6. It says, Stephanie deposited $1,500 into a savings account that earns 2.7% simple interest. How much interest will she have earned after 6 years? Okay, so this one has deposited $1,500 principal, 2.7% interest, that's our rate. How much interest, that's what we're looking for, and our time is 6 years. So this one's going to be pretty straightforward, just like the other ones. Let's start plugging stuff in. Interest equals 1,500 times 2.7 divided by 100. We do 1, 2. 0.027 times 6 years. So I'm going to start multiplying stuff. 1,500 times 0.027. 7 times 0 is 0. 7 times 0 is 0. 7 times 5 is 35. Carry the 3. 7 times 1 is 7. Plus 3 is 10. 2 times 0 is 0. 2 times 0 is 0. 2 times 5 is 10. Carry the 1. 2 times 1 is 2 plus 1 is 3. Now we're going to add it up. 0 plus 0 is 0. 0, 5, 0, 4. There are 3 numbers behind the decimal point in my question, so there will be 3 numbers behind the decimal point in my answer. So this becomes 40.5 times 6. So let's do that math now. 6 times 5 is 30. Carry the 3. 6 times 0 is 0 plus 3 is 3. And 6 times 4 is 24. There's 1 number behind the decimal point in the question, so there's 1 number behind the decimal point in my answer. My answer, interest is $243. There we go. Okay, I hope you got that. I'm going to make some space. What's good is that there were a couple of them that were the same, so we got to practice the same thing again and again. So let's take a look at number 7 together. It says, Jonathan's savings account balance is $3,240. If you originally deposited $2,700 into the account 4 years ago, what is the simple interest rate on the account? So let's take this deposited, which tells me this is my principal. 4 years gives me my time. What is the simple interest rate means I'm looking for the rate. What is missing? What's missing is interest. Does it give me the interest? No, it gives me account balance. Can I figure out what the interest is using the account balance? Yes, because an account balance is interest plus the original deposit or principal. Okay, so this gives me balance. If I want to find the interest, then I do account balance minus principal. So let's do that. Let's do it here. 3240 minus 2700. 0 minus 0 is 0. 4 minus 0 is 4. I can't do 2 minus 7, so I'm going to borrow from here. This becomes 12. 12 minus 7 is 5, and 2 minus 2 is 0. So $540 is my interest. Okay? Actually, let's move on. Let's plug it all in. So $540 is equal to principal, which was $2,700, the rate, which we do not know yet, and the time, which is 4 years. So first, we have to multiply these two numbers together. Let's do 2,700 times 4. 0, 0. 4 times 7 is 28, so I put an 8, carry the 2. 4 times 2 is 8, plus 2 is 10. There are no decimals, so that's it. We leave it just like that. So 540 is equal to 10800 times R. So now I have to divide by 108,000, and I have to do that on both sides. And why do I do that? Because I want to solve for R, so if it's multiplied to the R, I'm going to divide. So 540 divided by 180,000 gives me this. Oh, I put too many zeros. And I was just going to say, we have to be careful with the zeros because here it says 10,800. If we put the wrong number of zeros, it's going to give us the wrong answer. So I'm sorry I did that. Let's try this again. Sorry about that. 10,800. 10,800. This gets the R by itself. Here I can eliminate 2 zeros. So I'm left with 1080 and 54. So now, 1,080 goes into 54 0 times. I'm going to add a decimal and add a 0. 1,080 goes into 540, also 0 times, because 1,080 is too big. So now, I add another 0. 1,080 goes into 5,400. Okay. This is going to be probably like 5, because 1,000 times 5 gives me 5,000, and that's the closest. So let's do 1,080, I'm going to do it over here, times 5. 5 times 0 is 0, 5 times 8 is 40, put a 0, carry the 4. 5 times 0 is 0, plus 4 is 4, and 5 times 1 is 5, so it's exactly 5. Okay, so R equals 0.05. Now this is the part that's tricky. Remember that for us to get an interest and set it up as a rate, we have to divide by 100. So percent to rate, we divide by 100. Which means if I want to go back from rate to percent, I have to multiply by 100. So I have to multiply this by 100. Which means I move the decimal point 2 to the right. And that gives me 5%. Remember, and to explain that, when we were dividing by 100, we're moving the decimal point 2 to the left. But since we're doing the opposite now, we're going to move it 2 to the right, and that gives me 5%. So the correct answer is this, not this. Okay? All right, so that was a new one. I hope you got it. If you didn't, feel free to pause, go back, watch it again. You can always leave a question in the comments below. And when you're ready, we'll move on to number 8. Is $5,133. If you originally deposited $2,900 into the account 7 years ago, what is the simple interest rate on the account? So this is similar to number 7, okay? Let's go one by one. Deposited $2,900, that is principal. 7 years ago gives us time. It's asking us for the simple interest rate. What is missing? The interest. Remember that we have account balance, and principal plus interest equals account balance. So let's do 5133 minus 2,900, and this is going to give us the interest earned. So 3 minus 0 is 3. 3 minus 0 is 3. We can't do 1 minus 9, so we're going to borrow from the neighbor, and this becomes 11. 11 minus 9 is 2. 4 minus 2 is 2. So the interest earned is 2233. Okay? So now we're going to plug this into our equation. 2233 is equal to 2,900 times an unknown rate times 7 years. So let's do 2,900 times 7. Okay? So 2,900 times 7. 7 times 0 is 0. 7 times 0 is 0. 7 times 9 is 63. So I put a 3, carry the 6. 7 times 2 is 14. Plus 6 is 20. So 2233 is equal to 20300 times R. Okay? We checked. We have the right number of zeros. Now I'm going to divide. Okay? I'm going to divide by 20,300 so that I can isolate the R. So now, 20,300, 2233. This number is bigger than this number. So we're going to start off with a 0 and we're going to add a decimal point. 20,300 can go into 22,330. Yes, it can go one time. So I'm going to do 20300. I'm going to subtract 3 minus 3 is 0, 2 minus 0 is 2. Okay, I have 2,030 left over. So that means I have to add another 0 and bring it down. Because I want to have no numbers to bring down, and I want to have no numbers left over. So how many times does 20,300 go into 20,300? One time again. This time, there's nothing left over. So we don't have to add any more zeros. So my rate is 0.11. But I want to turn this into a percent. So I'm going to multiply it by 100. And this gives me 11%. Okay, I hope you got that. When you're ready, I'm going to move on to number 9. So number 9 says, Karen's savings account balance is $7,874. If she originally deposited $6,200 into the account 3 years ago, what is the simple interest rate on the account? So this one is just like the last one. So I want to encourage you, if you want to give it a try on your own to make sure you can do it without my help, then hit pause right now and do the question again. Maybe you already attempted and you got it wrong, but that's okay. Do the question again and see if you get the right answer. When you're ready, I'm going to go ahead and do the explanation now. So it says originally deposited $6,200. That's not my rate. Sorry, that's my principal. 3 years gives me the time, and it's asking me for the rate. What am I missing? Interest. So I'm going to do 7874 minus 6,200. I'm going to subtract. That gives me 4, 7, 6, 1. Okay, so interest equals 1674. Now I'm going to plug everything in. 1674 is equal to 6,200, which is the principal, an unknown rate that we don't know, and 3 years. So I'm going to multiply these two together. 6,200 times 3. 3 times 0, 0. 3 times 0, 0. 3 times 2, 6. 3 times 6, 18. So 18,600. I'm going to divide by 18,600 on both sides. Now I'm going to set up that division problem so I can finish. Now, this number is bigger than 1674. So I'm going to go 0 times, add a decimal, and add a 0. So can 18,600 go into 16,740? No, it's still bigger. So I'm going to put a 0, and I'm going to add another 0. Can 18,600 go into 167,400? Yes. So this one is a little challenging. I'm going to round this up to 20,000, and I want to see how many times I have to multiply to get to 160,000, and that's 8. So I'm going to try 9 because it's a little bit bigger, okay? So 18,600 times 9. 9 times 0 is 0. 9 times 0 is 0. 9 times 6 is 54. Carry the 5. 9 times 8 is 72. Plus 5 is 77. 9 times 1 is 9. Plus 7 is 16. So it actually gives me exactly the same number. So 167400. I subtract, and I'm done. So rate is equal to 0.09, which we now multiply by 100%, and that gives us 9%. Okay, I hope you got it. If you have any questions, just comment below, and I'd be happy to help you with it. Okay, so let's do number 10. It says, Gail's savings account balance is $14,080. If you originally deposited $8,800 into the account 10 years ago, what is the simple interest rate the account is earning? So this is just like the ones that we've done before. Deposited $8,800 is the principal, 10 years ago gives us the time. Simple interest rate is what we're looking for. Okay? And it doesn't give us the interest, but it does give us account balance, which is $14,080. Remember I told you that the account balance is your principal deposit plus the interest earned. Why is that the case? Because if you deposit $100 into a savings account and you earn $5 in interest, then the balance on your account after you've earned your interest is $105. $100 from your deposit, $5 from the interest earned. Okay? So if we want to know what the interest earned is and what we have is the account balance and the deposit, then we say, okay, let's subtract them, and that's going to give us our interest earned. Okay? So let's do it real quick here. 14,080 minus 8800. 0 minus 0, 8 minus 0, I can't do this, so I borrow. 10 minus 8 is 2. I can't do this either, so I borrow. 13 minus 8 is 5. So our interest earned is $52.80. So now let's put that into our equation because we have everything now. So our interest earned is $52.80, and this is equal to our principal, which is $8,800, times our unknown rate times 10 years. Okay, so we're going to multiply these two, 8,800 times 10. You can just add a 0 at the end because there's 1 0 here, but I'm going to do it the long way so you can see why that works. So 0, 0, 0, 0, placeholder 0, 0, 0, 8, 8. 0, 0, 0, 8, 8. So it's the same thing as adding a 0, okay? Now, let's plug that back into our equation times r. Now, I'm going to divide by 88,000 because I want to isolate the r. And when I do, look at that, I get to eliminate 1 0. So I'm working with smaller numbers. That's good. So now I'm going to do 528 divided by 8,800. So how many times does, let me get them a little closer, this looks weird. How many times does 8,800 go into 528? Well, it's too big, we can't do it. So we're going to put a 0, a decimal point, and another 0, okay? So how many times does 8,800 go into 5,280? Still 0 times, because 8,800 is bigger than 5,280. So I put a 0 up here. I add another 0. 8,800 goes into 5,280. All right, let me show you a quick thing here. All of these three have a 6 in them. So let's try 6. Let's do 8,800 times 6. And let's see what that gives us. 6 times 0 is 0, 6 times 0 is 0, 6 times 8 is 48, carry the 4. 6 times 8 is 48, plus 4 is 52. Look at that. It's exactly 6. And when I subtract, I get 0. I have no more zeros to bring down. So my rate is 0.06. Now I have to multiply by 100 to get that to be a percent, and I get 1, 2 to the right, which gives me a whole number, 6%. And that's my answer. Don't forget to skip this step. I'm sorry, not to. Don't forget to turn that rate into a percent. Don't skip that step. That's what I meant to tell you. Don't skip that step because there was a 0.06% here, and that is wrong. Okay? So remember to multiply by 100. Okay, let's do number 11. So it says, Daniela is saving up for a down payment on a car. She has already saved up $1,300 and wants to make a $2,000 down payment. If she wants to purchase the car in 18 months, what rate of simple interest does she need to earn on a savings account to reach her goal? Round the decimal to the nearest 10th place. Okay, so let's see. First of all, this is a different question than what we've been used to, but we're always welcoming challenges. So she has already saved up $1,300. That's how much she has in her hand, which means that's what she starts with. That's her principal. This is her goal, which means if we subtract it, we know how much more she needs. 2,000 minus 1,300, 0, 700. That is how much she needs, which is also what she wants to earn as interest. So this becomes our I, okay? Earn as interest. So this becomes our I, okay? She wants to purchase a car in 18 months. This is our time. But this time is in months. And when we use t in our equation, it has to be years. So how do we convert this to years? 18 months is to x years, as 12 months is to 1 year. So x times 12, 12x. 18 times 1, 18. 18 divided by 12. Remember, the numerator goes in the inside. The denominator goes on the outside. 12 goes into 18 one time. We add a decimal because we have a 6 left over. We bring down that 0. 12 goes into 60 5 times. So t equals 1.5 years. That's what we can put into our equation. And it's asking us for simple interest. We're looking for rate. So now that we have all this, let's plug it into our super awesome equation. So interest is 700. Principal is 1,300. We don't know the rate. And we know that it's 1.5 years. So let's do 1,300 times 1.5. I'm going to make a little bit of space here so I can multiply. So 1,300 times 1.5. 5 times 0 is 0, 5 times 0 is 0, 5 times 3 is 15, carry the 1. 5 times 1 is 5 plus 1 is 6. Now the 1. 0. Our placeholder 0. 1 times 0 is 0, 1 times 0 is 0, 1 times 3, 3, 1 times 1, 1. 0, 0, 5, 9, 1. There's one number behind the decimal point. So now 700 is equal to 1950 times r. We divide by 1950 on both sides of the equal sign. This lets me get my r by itself, and guess what? I can eliminate a 0, which is something I love to do because I get to work with smaller numbers. So now I'm going to do 70 divided by 195. First, 195 cannot go into 70. It goes in 0 times because it's too big. So we add a decimal and a 0. 195 goes into 700 3 times because 195 is pretty close to 200. So let's do this. 3 times 5, 15. Carry the 1. 3 times 9, 27 plus 1, 28. Carry the 2. 3 times 1 is 3 plus 2 is 5. So 585. Now I can subtract. 10, this becomes a 9. And it starts from over here. 10 minus 5, 5. 9 minus 8, 1. 6 minus 5, 1. I have a leftover, so I'm going to bring down another 0. So this is pretty close to 1,200, and this is pretty close to 200. So I'm going to assume it's going to be like a 6, okay? So let's try 195 times 6. Let's do it here. 195 times 6. 6 times 5 is 30, carry the 3. 6 times 9 is 54, plus 3 is 57, carry the 5. And 6 times 1 is 6, plus 5 is 11. Okay, so we're pretty close, but we actually went over. So let's try times 5. 5 times 5 is 25, carry the 2. 5 times 9 is 45, plus 2 is 47, carry the 4. 5 times 1 is 5, plus 4, 9. So 975, and I'm going to put a 5 up here. Okay, so I'm going to borrow from here. 10 minus 5 is 5. 14 minus 7 is 7. 10 minus 9 is 1. 175. So we're going to stop here for a second. Rate equals 0.35, okay, because the number's going to keep going. Now, we have to multiply by 100, which gives us 35%, and our closest one is 36%. That's why we know it's going to be there, because we were supposed to round to nearest 10th place. If we're going to keep going, this was probably going to round this up to 6, but we didn't, because the differences are really like 4 and 12, or 1.2. So those are big differences. So it's safe to stop there, okay? I hope you got that. If not, you're welcome to watch it again. When you're ready, I'm moving on to number 12. Okay, number 12 says, James deposits $400 into a savings account. Into an account that already has an existing balance of $900. If the account earns 4% simple interest, what will be his account balance after 2 years? So this one is weird because it says that he deposits into an account that already has an existing balance. So we're resetting the amount, and we want to know what the new amount will be after 2 years. So our principal is this number and this number added up. So 400 plus 900 added up, 0, 0, 13. That is our principal, okay? Our rate is 4%, which we divide by 100, and it gives us 0.04. 1, 2, fill it in with a 0. And our time is 2 years. So we can plug this into our equation and get the interest that it earns, okay? But what is the question asking us for? The account balance. Remember I told you the account balance is my principal plus my interest earned. So when we get our answer, when we get the interest earned, we solve for I, that's not the answer. We have to take that number and put it back and add it to the principal, okay? So let's not forget that, super important. So let's write my equation. So interest is equal to principal times 0.04 times 2. So let's do 1,300 times 0.04. I'll do that over here, 1,300 times 0.04. 4 times 0 is 0, 4 times 0 is 0, 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 is 52. There are 2 numbers behind the decimal point, which means there's 2 numbers behind the decimal point for me here. So now this is 52 times 2, right? Oh. Times 2. So 52 times 2, 2 times 2, 4. 2 times 5, 10. 104. So now I'm going to add that to my principal. 1,300 plus 104, 4041. So my account balance, or James' account balance after 2 years, will be 1,404. Okay, the math was not too hard on that one. These numbers were definitely easier to work with. But what made this one different is that we have 2 balances, or 2 deposits to worry about, so we have to add them to make up principal, okay? When you're ready, I'm going to move on to number 13. Number 13 says, Jessica is saving up for a laptop for school. She needs to save a total of $1,534. She received $1,300 in graduation gifts, which she deposited into a savings account that earns 4.5% simple interest. How long will it take to reach her goal? It's asking us how long, which means we're looking for time. So what does it give us? It gives us her goal, which remember, actually, let me not say anything yet. But it tells us what she's going to deposit. 1,300 is the principal. And it tells us the rate. Okay, so what does she need to earn? Well, we take her goal, we minus what she already has, okay, and we figure out how much interest she needs to earn. So 4 minus 0 is 4, 3 minus 0 is 3, 5 minus 3 is 2, and 1 minus 1 is 0. So she needs to earn $234 in interest. So now that we have interest, principal, rates, and we're looking for time, we can go ahead and plug stuff into our equation. So $234 is equal to $1,300, which is her principal, times rates, which I'm going to do 4.512, is equal to 0.045. Okay? 0.045 times time. So let's do 1,300 times 0.045. I'm going to do it over here. 1,300 times 0.045. 5 times 0 is 0. I don't know if I'm going to have enough space. Let me make a little space here. Sorry, give me 1 second. Okay, so 5 times 0 is 0. 5 times 0 is 0. 5 times 3 is 15. And 5 times, carry the 1. 5 times 1 is 5, plus 1 is 6. Okay? Now, placeholder 0, let's do the 4. 4 times 0 is 0. 4 times 0 is 0. 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 is 5. We don't have to do these zeros because they'll just multiply, and everything that multiplies to 0 is 0. So it would waste our time, so we don't need to do those. So 0, 0, 5, 8, 5. Okay? And there are 3 numbers behind the decimal point in the question, which means there'll be 3 numbers behind the decimal point in the answer. So we have 234 is equal to 58.5 times t. I'm going to divide by 58.5 on each side. And I'm going to do that because I want to, I want to isolate the t. I want to get rid of the 58.5. So now I'm going to divide. And I'm going to do 234 divided by 58.5. Remember, we have to move over 1 to the right. And when we do the inside, we do the outside, we also have to do the inside. And when we have a space like this, we fill it with 0. So now this becomes 585 and 2340. So how many times does 585 go into 2340? Well, this is really close to 600, and this is pretty close to 2400. So it's going to be somewhere around 4 years. Okay, so let's try 4. 585 times 4. 5 times 4 is 20. 4 times 8 is 32, plus 2 is 34, carry the 3. 5 times 4 is 20, plus 3, 23. So it's exactly 4. 2340. We subtract, and we get 0. There are no more numbers to bring down. There's nothing left over. So our answer in time is exactly 4 years, which is this answer choice right here. Okay, so I hope you're able to keep up. Feel free to watch it again if you need to. But when you're ready, let's go ahead and do number 14. So, number 14 says, Aaliyah deposits $5,700 into a savings account. After 12 years, Aaliyah checks the balance on the account and discovers that she has a total of $9,120 in her account. What is the simple interest on the account? So here it tells us deposits, that's our principal. 12 years, that's our time. Account balance, that's going to help us find out how much the interest is. And it's asking us for the rate, right? Okay, awesome. So, let's go ahead and subtract so we can find out what the interest earned is. Let's do 9120 minus 5,700. So 0 minus 0 is 0, 2 minus 0 is 2. I have to borrow here. 11 minus 7 is 4, and 8 minus 5 is 3. So the interest earned is 3,420. That's going to be my interest. Okay, so now let's plug it into the equation. 3,420 is equal to 5,700 times an unknown r times 12. So we have to multiply these two. So let's do 5,700 times 12. 2 times 0 is 0, 2 times 0 is 0, 2 times 7 is 14, carry the 1. 2 times 5 is 10, plus 1 is 11. And now let's move on to the 1, so let's put our placeholder 0. 1 times 0 is 0, 1 times 0 is 0, 1 times 7 is 7, and 1 times 5 is 5. 0, 0, 4, 8, 6. 68,400. There's no decimals, no anything, so that's how we leave it. 3,420 is equal to 68,400 times r. So now we divide by 68,400 on both sides to be able to isolate the r, and when we do that, we cancel these out. Now we have a division problem. So let me make some space. Okay, remember, the numerator goes in the inside, 342, and the denominator goes on the outside, 6840. Okay, how many times does 6,840 go into 342? 0 times, it's way too big of a number. So we're going to add a decimal, I'm going to extend that a little bit, and add a 0. How many times does 6,840 go into 3,420? 0 times again, because it's still bigger. So we add a 0 here. How many times does 6,840 go into 34,200? Well, 6,840 is pretty close to 7,000, and 34,200 is pretty close to 35,000. So I could do 7,000 times 5. Okay, cool. So let's try 6840 times 5. Let's see what it gives us. 5 times 0 is 0. 5 times 4 is 20. So I put a 0, carry the 2. 5 times 8 is 40, plus 2 is 42, carry the 4. 5 times 6 is 30, plus 4, 34. Look at that. It's exactly that number. So I'm going to put a 5 here, 3, 4, 2, 0, 0. I minus, and I have 0 left over, and I don't have any other numbers to bring down, so I'm done. So my rate is 0.05. But what am I missing? Is that my answer? No, it's not, actually. My answer is the percent. So I have to multiply by 100, and that gives me 5%. When I multiply by 100, I go 1, 2 to the right, and that makes it a whole number 5. So this is my answer here. Okay, awesome. So I hope you got that. If you're ready, then let's move on. Okay, so number 15, it says, Ben deposits $200 into an account that already has an existing balance of $2,400. If the account earns 3% simple interest, how much interest will his account earn after 7 years? So here, it gives us two numbers for the principal. The balance is $2,400, but he adds 200 to it. So we actually have to add these up to get our principal. So 0.062. That is our principal. It earns 3% simple interest, and that's our rate that we're going to turn into a decimal by dividing by 100. I go 1, 2, so it's 0.03. Okay, and it gives us the time, 7 years. What is it asking us for? How much interest? So that's pretty straightforward. Okay, so let's set up our equation. Interest equals principal, which is 2,600, times the rate, which is 0.03, times 7 years. Let's do 2,600 times 0.03. Okay, so 3 times 0, 0. 3 times 0, 0. 3 times 6, 18. Carry the 1. 3 times 2 is 6, plus 1 is 7. We have two numbers behind the decimal point, and we'll have it there also in our answer. So this becomes I equals, we've multiplied these two together, 78 times 7. What's 78 times 7? 7 times 8 is 56. Carry the 5. 7 times 7 is 49. Plus 5 is 54. So the interest earned is $546. And that's our answer. Okay? I hope you got it. Remember, if you have any questions, just leave a comment below, and I'll be happy to help you. Good luck.
Hey guys, this is Natalia again from ASVAB Success, and I just want to show you a quick video about how to do questions with temperature changes. This is a classic word problem for arithmetic reasoning. It's actually pretty easy to do, but sometimes if you don't know what it is, you can get confused with it. So this is just a quick rundown of how to do these questions. If you're ready, let's do them. All right, so temperature change questions basically means that we're switching from degrees Fahrenheit to degrees Celsius, or degrees Celsius to degrees Fahrenheit. So degrees Fahrenheit is how we measure temperature in the United States. Degrees Celsius is how they measure temperature everywhere else in the world. So it's really good to know how to switch between these two types of temperature measurements, or units of measurement. So the formula is always given to you, so you do not have to memorize the formula. This is the formula right here. And basically, what we're going to do is we're going to read the question, see what we're converting, and then plug stuff in. It's pretty easy, all right? So the question says, when the temperature is 50 degrees Fahrenheit, what is the temperature on the Celsius scale? Use the formula F equals 9/5 times C plus 32. So basically, it's telling us that we have 50 degrees in Fahrenheit. That means we're going to plug in 50 for wherever we see an F in our equation. And then we're looking for the Celsius, which means we're going to solve for Celsius. How do we solve for Celsius? Well, you haven't necessarily done the algebra class yet, so I'll explain to you real quick. What you do is you get it by itself on one side of the equal sign. Let me show you the example, and hopefully that'll make more sense. So I'm going to rewrite my equation here. And because I already know Fahrenheit, I'm going to replace it with 50. So let me rewrite that so it makes more sense. 50 equals 9/5 times C plus 32. Easy stuff, right? So now that we've not converted, now that we've plugged in the 50, now let's do the next steps. Well, we want to get the c by itself. Right now, the c has a 9 over 5 multiplied to it and a 32 added to it. So the first thing we're going to do is we're going to minus the 32. We're going to minus the 32 so that it can cancel out on this side. Whatever I do to one side of my equal sign, I have to do to the other side of my equal sign. So because I minus 32 on the right side, I also minus 32 on the left side. So 50 minus 32. 10 minus 2, 8. 4 minus 3, 1. So I get 18 equals 9 over 5 times c. Okay, and now we get to do the super fun part. We're going to get the c by itself. Right now, there's a 9 over 5 multiplied to it, so we're going to divide. How do we divide by a fraction? Well, we know how to divide by a fraction. This cancels out. I'm left with 18 divided by 9 over 5 equals c. So, real easy. 18 divided by 9 over 5. When we divide by a fraction, what we do is we flip what's behind the division and we multiply. So 18 times the reciprocal, 5 over 9. Okay, so now we put the 18 over 1, we multiply. 18 times 5, I'm going to do that over here. Gives me 90. 18 times 5 is 90. Over 1 times 9 is 9. So 90 divided by 9 gives me 10. That's how I solved it. So that was a little funky maybe. Totally okay. But that's it. My answer is 10 degrees Celsius. All right. Don't worry. I have another example for you coming up. If you need to pause or rewind, remember, this is a video. You can do that. So go back, look at it again. And if you're ready, let's move on to the next example. So in this next example, it's giving us the temperature in Celsius and it's asking us to go to Fahrenheit. So now it's the opposite. Okay. Now it says when the temperature is 30 degrees Celsius, that means 30 degrees goes wherever we see C. What is the temperature on Fahrenheit? That means we're solving for F. Okay, so we rewrite our equation. Okay, and wherever we see a C, we're going to replace it with 30. So the F stays there. You see how this one's different? We multiply this by 30. So I'm going to go parentheses, so I know how to do this first. And then I add 32. Okay, this one is different because I don't have to actually, I'm replacing different things. Okay, so pay close attention to that. The point here is that wherever we see a letter replaced, that's where we're going to put that number. So in this one, in this one, what I want to do is I want to multiply 9 over 5 times 30. So we put the 30 over 1. 9 times 30 gives me 270. And 5 times 1 gives me 5. So I'm going to simplify 270 over 5 by dividing. 5 goes into 27 5 times. I subtract, I get 2. 5 goes into 20 4 times. So 54. So 270 over 5 cancels out or simplifies to be 54 plus 32. So now 54 plus 32 gives me 86. So my answer here, 86 degrees. All right. Well, I hope that's helpful. Remember, all we have to do with these questions is plug in for F or for C, depending on what is given to us. And then we use our algebra skills to be able to solve. I hope this was helpful. You have the quiz below to give you a little bit of practice on these questions. And as always, if you have any questions, please feel free to leave the comments below.